Have you ever felt that as you're sitting here listening to my voice, there might be another you in a different world, making entirely different decisions from yours? Perhaps, at this very moment, a version of you in another dimension is a billionaire, or maybe an astronaut gazing at Earth from beyond the atmosphere. This isn't just a sci-fi movie plot, but a scientific possibility far more complex than we can imagine. Today, I will take everyone on a journey beyond the boundaries of time and space to explore the 10 dimensions of the universe that will change the way you see yourself and this world forever. Stop and listen, because the truth that is about to be revealed might be more unbelievable than any dream you've ever had. Dimensions 1 to 3, the foundation of reality. Before we dive into the mysteries of the multiverse, we must start with what we know best. Imagine a tiny point with no width, no length, and no height. That is the beginning, called the zero dimension. But when that point begins to move, it draws a straight line, becoming the first dimension. Here, there is only one direction, moving forward and backward on an endless line. No turning left or right, and certainly no height. And when that straight line begins to move sideways, it expands into a flat plane. This is the second dimension, like characters on paper, who can move forward, backward, turn left, and turn right, but they will never know the words up or down. Their world is flat and confined to a surface, until we add depth. Then we experience the third dimension, the world we live in now, a world with shape, volume, mountains that touch the sky, and oceans of unfathomable depth. The third dimension is a familiar home, but it is only the outer shell of a much grander reality. Dimension 4, the prison of time. Close your eyes for a moment and think of yourself right now. You are sitting, breathing in, breathing out. Everything seems to stand still in the third dimension, but in reality, you are being carried by an invisible current. That is the fourth dimension, or time. In this fourth dimension, time acts like a long road that forces us to move forward in only one direction. We cannot turn back to change the past, and we cannot jump into the future. We are like fish carried by the current, with the clock's hands marking the heartbeat of the universe. For us, as three-dimensional beings, time is a straight line. But from the perspective of a physicist like Albert Einstein, time is not separate from space, but woven together to become spacetime. Imagine that your life, from birth to death, is not just a series of events that happen and disappear, but a long string stretching out in the fourth dimension. Every moment of your life, from your first cry to your last breath, all of it exists and remains forever in the fabric of space-time. It's just that our senses choose to perceive it one moment at a time, like a flashlight slowly illuminating that string in the dark. The terrifying and beautiful aspect of the fourth dimension is its transience. Because we see time as a straight line, we fear death, we yearn for the past, and we worry about the future. But what if I told you this is just the beginning? What if time isn't just a straight line, but a much larger fabric? Dimension 5, the world of choices and parallel paths. Welcome to the fifth dimension. Here, the rules of time as we know them are broken. If the fourth dimension is a straight line, the fifth dimension is a plane of time. Think of important events in your life. The day you chose to pursue further education. The day you decided to tell someone you loved them. Or even the day you chose to wake up late. In the fourth dimension, You could only choose one path. But where did the other path you didn't choose go? In the fifth dimension, those choices didn't disappear. Instead, they branched out into parallel universes. Every decision you make creates a new path. In this dimension, there is a version of you who is most successful, and a version of you who is most unsuccessful. All exist simultaneously, like a book with multiple endings, but you are only reading one page. This is the many worlds interpretation theory, which states that our universe is constantly splitting. Every time a quantum event occurs, the universe is separate. If you could see the world in the fifth dimension, you would see yourself as a massive tree with countless branches. Each branch is one possibility of life. Regrets or sorrows from the past would become meaningless, because in the fifth dimension, everything you wished for has already happened somewhere. But even with countless choices, every choice in the fifth dimension still operates under the same laws of physics, still has the same gravity, the same speed of light. What if there were universes where the fundamental laws were different? That's where we're going in the next dimension. Dimension 6, the infinite multiverse. If the fifth dimension is seeing all the choices in our lives, the sixth dimension will take us much further, because this is the level of the true multiverse. In the sixth dimension, we are not just talking about different choices within the same universe, but we are talking about universes that started differently altogether. Imagine a universe where the Big Bang occurred with a different amount of energy, or a universe where gravity was so weak that stars couldn't form, or even a universe where time flows backward from the future to the past. The sixth dimension is the space that contains every possible universe with different laws of physics. If you could travel in this dimension, you could jump from one universe to another instantly, like changing TV channels, where each channel has an entirely different program. The wonder of the sixth dimension is that it tells us the reality we see is only the smallest fraction of the whole. We are like ants walking on a piano. We hear only a single note, but in the sixth dimension, the entire song is playing simultaneously. Every form of matter, every form of energy, and every form of life that physics allows to exist, all are contained here. Dimensions 7 and 8, the lattice of possibilities. As we step into the seventh dimension, our minds will be challenged even further, because this is the beginning of infinite possibilities. In the sixth dimension, we saw different universes. But in the seventh dimension, we are talking about universes that are completely unrelated to each other. It is the convergence of all multiverses, all laws of physics, and every imaginable event. Imagine the seventh dimension as a massive blank canvas, with countless paintings superimposed on each other. Each painting is one multiverse. Here, there is no beginning and no end. It is boundlessness at a level we cannot describe with ordinary language. And as we move up to the eighth dimension, we begin to see the connections. This dimension acts like a lattice, or a compact spiderweb that binds all universes together. In the eighth dimension, we can see the history of all universes simultaneously, like looking at a city plan from a high vantage point. We will see why one universe came into existence and why another faded away. It is the level of information, where everything is a complex computer code. If the third dimension is the body, the fourth dimension is movement, then the eighth dimension is the blueprint of all reality. Here, the distinction between matter and thought begins to blur, because everything is a vibration of energy within this grand lattice. Dimension 9. The ineffable unity. Before we reach the pinnacle, we must pass through the 9th dimension, which is one of the most astonishing dimensions, because it is the point where all differences vanish. In the 9th dimension, all the different laws of physics, all the universes that were once separate, begin to merge into a single central point. It is the state of unity, or what philosophy calls non-duality, the state of not being two. Imagine a vast ocean. Each wave might seem different, some big, some small, with different foam patterns. But when those waves subside, they are all the same water. The 9th dimension is that state itself. It is the essence of the universe, devoid of form, devoid of time, and devoid of self. Here, you are not you, and I am not I, but we are one at the most fundamental level. Pain, joy, birth, and death, all are events that occur on the surface of this unity. In the 9th dimension, silence is the loudest sound, and emptiness is the most fulfilling thing. This is the level where science and spirituality begin to converge. Physicists might call it the theory of everything, while philosophers might call it the cosmic mind. Whatever you call it, the 9th dimension is the reality that everything is one. But there is still one more dimension above, the final dimension that is the end of all questions and the beginning of all answers. Dimension 10, the perfect beginning and end. And so, we arrive at the pinnacle of this journey, the 10th dimension. In mathematics and string theory, the 10th dimension is the highest limit that human imagination can reach. If the 9th dimension is the merging of everything, the 10th dimension is the state that contains everything within itself, both what is possible and what is impossible. Imagine a single point, but that point is not an ordinary point. It is a point that contains every universe, every space-time, every law of physics, every thought, every feeling, and every infinite possibility within itself. It is the absolute, beyond which nothing else exists. In the 10th dimension, the beginning of the Big Bang and the end of the universe are the same point. Life and death are the same. Emptiness and fullness are the same. It is infinity that has contracted into a single point. This is the point where language fails and the human brain can no longer process. Because in the 10th dimension, time does not exist. Distance does not exist. There is only the purest existence. If the universe is a book, the 10th dimension is the library that contains every book ever written and yet to be written, including books no one can read. Conclusion and closing philosophy. Who are we in this universe? After we have journeyed through all 10 dimensions together, you might feel incredibly small. Amidst a multiverse so vast and complex, we are merely three-dimensional beings, confined within the 4th dimension of space-time, on a tiny planet in a dark corner of the galaxy. But I want you to try looking at it from a different perspective. If all these dimensions truly exist, that means the you sitting here is also a part of that grand structure. Every atom in your body, the energy that drives your thoughts, all are connected to the 10th dimension. You are not just an observer of the universe, but you are the universe becoming aware of itself. Every day you wake up and make choices. You are creating new branches in the 5th dimension. Every time you love someone, you are touching the vibrations in the 8th dimension. And every moment you enter into stillness, you are returning to the unity in the 9th dimension. The universe is not out there, but it is within you. The greatest philosophy of the multidimensional universe is not about numbers or theories, but it is about realizing that we are a part of everything, and everything is a part of us. Our life in the fourth dimension might seem short and limited, but that is what makes it the most beautiful. Because in that endless infinity, your existence here, breathing, loving, and learning, is the greatest miracle in all dimensions. Live your life in the dimension you are in now to the fullest. Because no matter how many millions of you exist in other dimensions, this version of you, who is aware of the beauty of this present moment, is truly unique. Imagine this. What if you walked to the edge of the world and found that the world had no end? But what if you traveled back in time to the very beginning of all things, the point scientists call the Big Bang? The most terrifying question isn't how did it happen, but rather, what was there before that? Emptiness? God? Or is our universe merely a single breath in an endless cycle? Today, we will take you across the wall of time to find answers humanity never expected. Welcome to the furthest journey human intellect can reach. We all know that. Our universe began approximately 13.8 billion years ago, from a tiny point of immense density and temperature, which we call the singularity. But the problem is, all the physics theories we have, whether it's Einstein's theory of relativity or quantum mechanics, they all break down when they reach that point. It's like watching a great movie, but the opening reel has been destroyed. We see the explosion, we see the expansion, we see stars and galaxies, but we don't see the hand that lit the fuse. Renowned physicist Stephen Hawking once compared it to asking what was there before the Big Bang is like asking what is north of the North Pole, because from his perspective, time was only created along with the Big Bang. Therefore, the phrase before that has no mathematical meaning, but that is just one answer. There is another group of scientists who believe that before the Big Bang, there was something more exciting than emptiness, something that might change our understanding of our existence forever. We are talking about eternal inflation and conformal cyclic cosmology. Prepare yourselves, because what lies beyond this wall may make you feel that the universe we live in is much smaller than you ever imagined. Imagine soap bubbles in boiling water. Each bubble that emerges is a universe. This is the concept called eternal inflation, proposed by physicists like Alan Guth and Andre Linde. This theory tells us that our Big Bang is not the beginning of everything, but it is merely a local event that occurred in a much larger area, an area called the multiverse. In this multiverse, there is a state called false vacuum. It is a state with immense energy, and it is inflating rapidly, faster than light, and most importantly, it inflates eternally. But at some point, this surging energy will decay or stop inflating, like air bubbles forming in boiling water. When that bubble stops inflating, the remaining energy will be converted into matter and radiation. That is what happened the moment our Big Bang was born. That means, before our Big Bang, there was an energy field that was inflating. And while you are listening to this clip, there might be millions of other Big Bangs occurring in distant areas that we can never reach. Just think, if this theory is true, our universe is just a small soap bubble in an endless ocean, and our before is the chaos of energy creating new universes. No beginning and no end. But this is just one theory, because there is another concept that says our before might be the end of another universe that flourished before us. A theory that transforms the straight line of time into a perfect circle. That is, conformal cyclic cosmology, the work of Nobel laureate physicist Roger Penrose. Let's see how this circle of time works. If eternal inflation is countless soap bubbles emerging, conformal cyclic cosmology, or CCC for short, is the breath that goes in and out endlessly. This theory was proposed by Sir Roger Penrose, a Nobel laureate physicist. He suggests that our universe does not have a beginning and an end, but it is a cycle called aeons. Imagine our universe in the far future, billions and billions of years from now. When the last star dies out, every black hole evaporates into radiation through a process called Hawking radiation. At that time, the universe will only be left with light, photons, and massless particles. The universe will expand vastly until everything is empty. And this is the most astonishing point of this theory. When the universe expands to its limit, and only massless particles remain, distance and time will begin to lose their meaning, because massless particles do not perceive time. Mathematically, the state where the universe expands to its limit will be mathematically identical to the state where a new Big Bang occurs. It is a conformal rescaling that makes the end of the old era become the beginning of a new era without a seam. That means our before the Big Bang is the end of the universe that existed before. We are the ashes from the fire of the previous era that were rekindled to create something new. But this theory is not just imagination. Penrose believes that we might find evidence of the universe before, remaining in the cosmic microwave background. He calls them Hawking points, which are imperfections of energy, caused by the collision of supermassive black holes in the previous universe. If this is true, it's chilling that everything we see today might just be a repeated lesson in a notebook with no final page. But what if the universe didn't originate from something that already existed? What if it came from true nothingness? How do we explain this? Let's move on to the mystery of the quantum world. If we don't believe in cycles and we don't believe in multiverse, how do we explain the beginning of everything? The answer might be hidden in the smallest world, called quantum mechanics. That is the concept called quantum fluctuation. Think of vacuum. In general understanding, a vacuum is empty space. But in the quantum world, emptiness doesn't truly exist. A vacuum is a sea of energy that is constantly moving. There, particles and antiparticles will pop in and pop out in an instant, like tiny bubbles in soda. Physicists suggest that our Big Bang might just be the biggest quantum fluctuation that occurred in emptiness. It is a state called ex nihilo, or from nothing, which mathematically the total energy of the universe. When adding the positive energy of matter with the negative energy of gravity, the result might be exactly zero. That means our universe is the ultimate free lunch. We don't need any ingredients to create the universe. Other than emptiness and the laws of physics, that's all. But wait, we are using the words before, beginning, and time. But how sure are we that these things truly existed before the Big Bang? This is where Stephen Hawking and James Hartle proposed the most challenging concept, called the no-boundary proposal. They view that, when we go back in time near the Big Bang, time will gradually change its properties, becoming space. It is a state called imaginary time. In this state, the universe has no beginning, but it has a rounded surface, like the surface of the Earth. Imagine this. If you walk to the North Pole, you will find that there is no north direction anymore. Similarly, if you go back in time to the Big Bang, you will find that there is no before anymore, because time has already become part of space. Therefore, the question, what was there before the Big Bang, might be the wrong question from the start, because time is not a straight line drawn from eternity, but it is a property of our universe itself that just appeared. It's like asking, which page is the first letter on? The answer is, it's not on a page, but it is what creates the story on that page. So how do we conclude this? Since every theory leads us to different wonders, emptiness, cycles, or multiverses, the truth might be hidden in a place we cannot yet see. Let's move to the final conclusion that will change your perspective on life forever. We have come a long way, from the singularity wall, through the multiverse that inflates eternally, to the cycles of endless aeons. Whatever the true answer may be, one thing we discover is the wonder of intelligence that tries to understand the unseen and explain the non-existent. Just think, if the universe is a cycle, we are part of a story that has happened countless times before. If the universe is a multiverse, we are just one of millions of possibilities. And if the universe originated from emptiness, we are living proof that nothing can become everything. From a philosophical perspective, asking what was there before the Big Bang may not be about finding the beginning of time, but it is about finding the meaning of our existence now. Because if the universe has no true beginning, that means now is the most important point. We are not just dust in an empty universe, but we are the eyes that the universe uses to look at itself. We are the thoughts that the universe uses to understand itself. Renowned astronomer Carl Sagan once said, "We are made of star stuff." But if we look deeper than that, we might be the stuff of nothingness. That is trying to find the answer. Why we exist. Before the Big Bang, there might have been everything, or there might have been nothing. But the most important thing is right now. You are here, learning, and being part of the greatest mystery. Thank you for joining us until the end. If you like mysterious stories of the universe like this, don't forget to subscribe and share your thoughts below. What do you think? What was there before the Big Bang? Emptiness? Or someone? You ever stood under a pitch-black sky and felt like you were being watched by the void? The moment you gaze up at the stars, you might think that's all there is to the universe. But the most terrifying and beautiful truth is that those stars are just tiny soap bubbles floating in an invisible ocean. 95% of what exists, we humans don't have a clear name for it. We can only call it darkness. In the next 60 minutes, I'll take you diving beneath the surface of reality to see the secret structure that weaves this universe together. A structure that might suggest that you are not who you think you are, and this world might just be a shadow of something far grander. Don't blink yet, because we're about to begin a journey, the furthest humanity can reach. Let's start with what scientists call the crisis of reality. Imagine you're looking at a massive swirling storm. Our Milky Way galaxy is just like that. It spins at incredible speeds, but something is wrong. According to Newton's and Einstein's laws, the galaxy should be tearing itself apart, like a spinning amusement park ride flinging children off, because the stars at the outer edges are spinning too fast for the gravity of visible stars to hold them. But it doesn't break apart. It still holds together tightly. That means there must be an invisible hand holding these galaxies together. We call it dark matter. It doesn't reflect light. It doesn't absorb light. Light passes through it as if it doesn't exist. But it has weight, and its weight is the primary structure of the universe. Dark matter isn't just in distant space. It might be flowing through your body right now. Billions of particles per second, without you feeling a thing. Think about it. We live in a house built from materials we can't see. We walk through walls we can't touch. This is the first truth humanity must accept, that all 5 of our senses are designed to perceive only a fraction of reality. And then there's antimatter. When the Big Bang happened, the universe should have created equal amounts of matter and antimatter. And when they met, they would annihilate each other, leaving only light. If that were the case, the universe should be empty, no stars, no us. But why did antimatter disappear? And why did normal matter win that battle? Or is there some secret rule that intentionally chose for us to exist? We'll encounter the most astonishing structure in nature, the cosmic web. It's not a scattered void, but the universe is woven with filaments of gas and dark matter, stretching across billions of light years of emptiness. These filaments we call filaments. They are like the universe's main arteries, transporting matter to nourish various galaxies. The chilling part is this. In 2017, researchers from Italy used software to compare the structure of the cosmic web with the neural networks in the human brain. The result was the density, the connection patterns, and the distribution of nodes. It was almost an identical blueprint. Our brain has about 70 billion neurons, and the universe we know has about 100 billion galaxies. These numbers are surprisingly close, aren't they? This has led some physicists to question the theory of panpsychism, or the idea that consciousness doesn't originate from the brain, but consciousness is the essence of the universe. Or simply put, the universe might be a giant brain that is thinking, and each of us is a tiny neuron, processing feelings and thoughts. If this theory is true, every time you think, every time you feel, that vibration might travel along the cosmic web and affect the structure of the universe in ways we can't yet imagine. We are not accidental anomalies on Earth, but we are an organ of the universe, performing the function of awakening the darkness that surrounds us. But the wonder doesn't stop at physical structures, because in the next part, we will transcend the limits of dimensions to explore something even more mysterious than matter. That is, time, and the question of whether past, present, and future truly exist, or are merely illusions created by our brains. You ever wondered why we can remember the past, but not the future? Why can't a broken egg put itself back together? In the world of physics, most laws work both ways, whether moving forward or backward. But there's one law that stands in the way, that is entropy, or the law of disorder. This law states that everything in the universe will always move from order to disorder. And this is what creates the arrow of time. But what's even more surprising is the theory called block universe. This theory suggests that past, present, and future actually exist all at once, like frames in a movie reel. The moment you were born, the moment you are listening to me now, and the last moment of your life, all are already written in the structure of space-time. The feeling that time flows forward might just be a limitation of the human brain, unable to process all information simultaneously. Imagine this. If we could step outside the universe, we would see all of time laid out like a map. There's no too late and no not yet arrived. Everything is an eternal present. And if time is just another dimension, like width and length, can we travel through it? Einstein said, yes. The faster you move, the slower your time will pass. This isn't just a theory, but a proven reality. Clocks on GPS satellites run slightly faster than clocks on Earth because they are further from Earth's gravity. That means time is not constant, but it is a fabric that can stretch and contract according to the gravitational pull and energy of the universe. We've reached the deepest point of the secret structure. New generation physicists are beginning to believe that the most fundamental basis of the universe is not matter, not energy, but it is information. Every atom in your body, every memory in your brain, is a set of zeros and ones at the quantum level. This leads us to the holographic principle, which we briefly mentioned before, but this time we'll delve deeper. It has been discovered that the amount of information a black hole can store doesn't depend on its internal volume, but it depends on its surface area. It's like you have a gift box, but instead of putting things inside the box, the information of that gift appears on the wrapping paper instead. If this is true for black holes, scientists like Leonard Susskind and Stephen Hawking suggest that our entire universe might be like that too. The 3D sensation you are experiencing right now might just be a projection of 2D information stored at the furthest boundary of the universe. If that's truly the case, what is your self sitting here? Are you an avatar of code existing millions of light years away? And if information is the foundation of everything, who is processing this information? Is the universe a massive supercomputer running the life program? You ever stood under a pitch-black sky and felt like you were being watched by the void? The moment you gaze up at the stars, you might think that's all there is to the universe. But the most terrifying and beautiful truth is that those stars are just tiny soap bubbles floating in an invisible ocean. 95% of what exists, we humans don't have a clear name for it. We can only call it darkness. In the next 60 minutes, I'll take you diving beneath the surface of reality to see the secret structure that weaves this universe together. A structure that might suggest that you are not who you think you are, and this world might just be a shadow of something far grander. Don't blink yet, because we're about to begin a journey, the furthest humanity can reach. Let's start with what scientists call the crisis of reality. Imagine you're looking at a massive swirling storm. Our Milky Way galaxy is just like that. It spins at incredible speeds, but something is wrong. According to Newton's and Einstein's laws, the galaxy should be tearing itself apart, like a spinning amusement park ride flinging children off, because the stars at the outer edges are spinning too fast for the gravity of visible stars to hold them. But it doesn't break apart. It still holds together tightly. That means there must be an invisible hand holding these galaxies together. We call it dark matter. It doesn't reflect light. It doesn't absorb light. Light passes through it as if it doesn't exist. But it has weight, and its weight is the primary structure of the universe. Dark matter isn't just in distant space. It might be flowing through your body right now. Billions of particles per second, without you feeling a thing. Think about it. We live in a house built from materials we can't see. We walk through walls we can't touch. This is the first truth humanity must accept, that all 5 of our senses are designed to perceive only a fraction of reality. And then there's antimatter. When the Big Bang happened, the universe should have created equal amounts of matter and antimatter. And when they met, they would annihilate each other, leaving only light. If that were the case, the universe should be empty, no stars, no us. But why did antimatter disappear? And why did normal matter win that battle? Or is there some secret rule that intentionally chose for us to exist? We'll encounter the most astonishing structure in nature, the cosmic web. It's not a scattered void, but the universe is woven with filaments of gas and dark matter, stretching across billions of light years of emptiness. These filaments we call filaments. They are like the universe's main arteries, transporting matter to nourish various galaxies. The chilling part is this. In 2017, researchers from Italy used software to compare the structure of the cosmic web with the neural networks in the human brain. The result was the density, the connection patterns, and the distribution of nodes. It was almost an identical blueprint. Our brain has about 70 billion neurons, and the universe we know has about 100 billion galaxies. These numbers are surprisingly close, aren't they? This has led some physicists to question the theory of panpsychism, or the idea that consciousness doesn't originate from the brain, but consciousness is the essence of the universe. Or simply put, the universe might be a giant brain that is thinking, and each of us is a tiny neuron, processing feelings and thoughts. It tells us that humans are not just observers who accidentally appeared on a small planet, but we are the eyes and heart of the universe. This vast universe, if there were no conscious beings to perceive it, would just be meaningless darkness. But because of you, because of your curiosity, because of your love and your pain, the universe truly exists. You are the channel through which the universe experiences itself. You are the pen with which the cosmos writes its story. On days when you feel tired or feel worthless amidst the chaotic world, please remember these secret structures. The atoms in your body were once part of stars. Your information is eternally recorded in the horizons of the universe, and your consciousness is connected to all things through an unbreakable quantum thread. You are a miracle that took 14 billion years to create. Don't underestimate yourself, and don't stop asking questions, because every question you ask is moving the structure of reality forward. The universe isn't out there waiting for us to discover it, but it's dancing in every breath you take. Thank you for joining us on this epic journey of reality. May the light of knowledge and the peace of philosophy be with you always. Just imagine, in another dimension, right now, as you're listening to my voice, there might be another you, living a life in a different universe, where every decision you've made is different. Every path you've chosen leads to a different outcome. That other you might be happier or sadder, more successful, or facing even greater challenges. And what if these possibilities aren't just a dream, but a scientific reality that is being seriously explored? How would you feel if we might not be living in a single universe after all? Hello, dear listeners. Welcome to a moment where we will explore the mysteries of the universe and our own existence together. Today, I want to invite you to ask a question that might change your perspective on the world and on yourself forever. The question is, might we not be living in a single universe? The concept of the multiverse is not new. It has appeared in myths, literature, and films for a long time, but currently it has entered the realm of science and philosophy in a serious way. Many scientists and philosophers are beginning to ask if the universe we inhabit might be just one of countless universes existing simultaneously or continuously. Close your eyes slowly and imagine possibilities without limits, beyond what you have ever perceived, beyond the universe we see with our eyes and feel with our senses. It is a concept that is both exciting and daunting at the same time, because it challenges everything we once believed about reality and our place in the cosmos. If the multiverse concept is true, that means every small decision you've ever made in life, every crossroads you've chosen, might create a new universe where another you is living with the consequences of different decisions. In one universe, you might have chosen to study your dream field and succeeded in that path, while in another universe, you might have chosen a different path and are learning from mistakes or discovering happiness in a different way. It's like standing in front of a giant mirror, reflecting millions of images of ourselves. Each image is a version of us in a different universe, with its own life, feelings, and story. Before we dive into complex theories, let's understand the basic concept of the multiverse first. Generally, the multiverse concept can be divided into several types, but its core is the existence of more than one universe, which may differ in terms of physical laws, natural constants, or even history and events. Imagine, our universe is like a single soap bubble, floating in a vast bathtub, filled with countless other soap bubbles. Each soap bubble is a universe, with its own rules and stories. Some bubbles might be close enough to touch, some might be so far apart that they can never interact. Scientists and philosophers have proposed many forms of multiverse theories, each with different concepts and supporting evidence. Let's explore some prominent theories. The many worlds interpretation comes from quantum mechanics, which describes the behavior of very small particles. In the quantum world, particles can exist in multiple different states simultaneously until we make a measurement. When we make a measurement, the particle chooses one state and the other states disappear. But this theory proposes that the other states don't disappear. Instead, they branch off into parallel universes, where another you is experiencing a different outcome. That means, every time a quantum event occurs, the universe branches into multiple universes, each containing all possible outcomes of that event. Just think, every second, countless quantum events occur. That means the universe is constantly branching, creating new universes all the time. Another theory is bubble universes, or cosmic foam. This comes from the concept of cosmic inflation, which was a period when the universe expanded rapidly after the Big Bang. Some forms of inflation theory suggest that this expansion didn't happen just once, but continuously in many areas, leading to the creation of many bubble universes. Each bubble is a universe, with different physical laws and natural constants. Imagine, our universe is like a small soap bubble, floating in a vast ocean of other soap bubbles. Some bubbles might be much larger than us, some might be smaller, and some might have just formed. It is a picture of an infinite universe, full of diverse and completely different possibilities. And that means, in those universes, there might be life forms completely different from us, or there might be worlds similar to ours, but with slightly altered histories, or even a version of you listening to this podcast, but in a completely different environment. And what if all of this is just a simulation? This concept suggests that the reality we are experiencing might just be an incredibly complex computer program created by a much more advanced civilization than us, like the computer games we play every day. But a game so realistic that we cannot distinguish if this is real or just an illusion. This concept has gained significant attention from philosophers and scientists, especially as our computer technology advances, allowing us to create increasingly realistic virtual worlds. The question is, if we can create realistic simulations, why couldn't a more advanced civilization do the same? And if we are in a simulated world, who is the creator? And what is the purpose of this simulation? Are we just characters in a game, or do we truly have free will? Then there's the mathematical multiverse. This theory might sound the most complex, but it is also one of the most interesting concepts. Max Tegmark, a physicist from MIT, proposes that every possible mathematical structure exists as a physical universe. That means not just universes with laws of physics similar to ours, but also universes with completely different mathematical rules, which might be beyond our imagination. It's as if mathematics is not just a language we use to describe the universe, but the universe itself. And every correct mathematical equation represents a reality that truly exists. Of course, these theories still lack clear scientific proof. They remain within the realm of hypotheses and speculation. But the fact that we can even conceive of these possibilities is amazing in itself. It makes us question what we believe to be true and what we believe to be impossible, and opens the door to exploring the limitless possibilities of the universe. But the deeper question is, if there are many universes and many versions of you, what is our true identity? Are we the person listening to this right now, or are we the sum of all our versions in all universes? This question invites us to consider the meaning of identity, whether it is something fixed or something that changes with decisions and experiences in each moment. In the context of the multiverse, our identity might not be limited to a single universe, but it might extend across all universes where we exist, and every version of us is part of a larger self. And if every possibility comes true in some universe, how much meaning do our decisions in this universe have? Do our choices, our actions, still matter if there's another version of us who chose the opposite? This question connects to the concept of free will. If everything is predetermined in some universe, do we truly have the freedom to choose? Some might feel that, if that's the case, life might be meaningless, because no matter what we choose, there will always be another version who chose differently. But from another perspective, it might make us appreciate the value of our present decisions even more, because this is our path in our universe, and every choice, every action, creates the version of ourselves we are in this moment. It is an acceptance that even if there are many other versions of you in other universes, you in this universe are unique and have the freedom to create your own story. Our decisions in this universe impact our lives in this universe, and that is something we can control. The concept of the multiverse is not just a distant scientific story, but it profoundly impacts our understanding of ourselves and our daily life decisions. If there are other universes where every possibility comes true, then how much meaning do our choices in this universe have? Do our actions still matter if there's another version of us who chose the opposite? Just think, if you are facing a difficult decision in life, thinking about the multiverse concept might help you see things from a broader perspective. No matter which path you choose, it will be the right path for you in this universe. And in another universe, another you is learning from a different path. It might free us from past regrets or future anxieties, because everything is part of limitless possibilities, and every choice leads to learning and growth in its own way. It is an open mind to accept uncertainty and the diversity of reality. Although the multiverse concept is exciting and imaginative, there are limitations and questions that are still debated among scientists and philosophers. One of the main arguments is the lack of clear empirical evidence. Most of these theories remain mathematical and physical hypotheses that cannot yet be proven by direct experimentation or observation. Some critics view that referring to the multiverse to explain certain phenomena might be avoiding finding true answers in our own universe, or creating theories that are unnecessarily complex to answer questions that have no answers yet. Furthermore, if there are countless universes with different physical laws, then what makes our universe have laws so miraculously suitable for the existence of life? This is what is called the fine-tuning of the universe, which some see as evidence of a designer, while others believe that if there are enough universes, then some universes are bound to coincidentally have properties suitable for the existence of life. In the end, whether we believe in the multiverse concept or not, exploring these ideas is still valuable. It invites us to explore the depths of reality and the meaning of existence. It stimulates us to think about our place in the vast universe and our relationship with limitless possibilities. It makes us realize that our knowledge of the universe is still limited, and there are many mysteries waiting to be discovered. What do you think? Might we not be living in a single universe? And if so, how will you live your life in this universe to make it the most valuable and create your story to be the most unique? Because no matter how many universes there are, this universe is the one you are living in, and every moment of yours always has meaning. Imagine for a moment that what we see in the universe might not always be the truth. The starlight we gaze upon could be distorted, bent by a mysterious energy, invisible to the naked eye. And sometimes that distortion creates something breathtakingly beautiful, like a piece of cosmic art. Scientists call it an Einstein ring. This phenomenon isn't just a wonder of physics, it's a vital key to unlocking the secrets of the universe, from dark matter to dark energy. Today, we're going to dive deep into the story of these rings of distorted truth. Get ready, because what you're about to hear will change the way you look at the universe forever. Welcome to our channel, where we explore the mysteries and wonders of the cosmos. We're talking about an astronomical phenomenon that is both stunning and incredibly significant, the Einstein ring. The name might sound complex, but I promise you, the story behind it is just as fascinating as the name itself. An Einstein ring is a cosmic illusion that occurs when light from a distant galaxy travels past a massive object in its path, like a large galaxy or a cluster of galaxies. This massive object acts like a giant lens, bending the light into a perfect ring right around itself. This isn't just a pretty picture, it's powerful evidence that confirms Albert Einstein's general theory of relativity. And it's also a crucial tool that helps scientists see things that are far beyond our normal reach. Over the decades, astronomers have discovered many Einstein rings, each telling its own unique story. And recently, the European Space Agency's Euclid Space Telescope caused a major stir by discovering a perfect Einstein ring that is closer to us than any we've ever seen before. This discovery doesn't just reinforce our understanding of the universe, it opens the door to solving some of the greatest mysteries of the cosmos: dark matter and dark energy. In this video, we'll take you through the history of this concept, from the birth of general relativity to Euclid's incredible discovery. We'll explore how Einstein rings are formed, why they matter to science, and most importantly, what this phenomenon tells us about the nature of reality and the philosophy we can learn from it. Get ready for an eye-opening journey into the heart of a phenomenon the universe uses as a mirror to reflect its deepest truths. Before we can truly understand the Einstein ring, we need to go back to its roots, the general theory of relativity, which Albert Einstein introduced in 1915. This theory revolutionized our understanding of gravity. Instead of seeing gravity as just a pull between masses, Einstein proposed that gravity is the result of the warping of space-time, a four-dimensional fabric that weaves together the three dimensions of space and the one dimension of time. Imagine a tightly stretched sheet. When you place a bowling ball in the center, the sheet curves downward. If you roll a small marble near the bowling ball, the marble will curve toward it, not because of a direct pull, but because the sheet itself is warped. In the same way, massive objects in the universe, like our sun, stars, or galaxies, warp the space-time around them. And this warping affects the path of everything moving through it, including light. This is the key point. Einstein predicted that light, which was once thought to always travel in a straight line, must bend when it passes near a massive object. This phenomenon is called the gravitational deflection of light, or more broadly, gravitational lensing. This idea was first proven in 1919 by the British astronomer Sir Arthur Eddington. During a total solar eclipse, he observed that the positions of stars near the Sun shifted slightly from their normal spots, exactly as Einstein had predicted. This discovery made Einstein a global celebrity, and the general theory of relativity became widely accepted. Once we understand that gravity can bend light, the concept of gravitational lensing becomes much easier to grasp. Think of a glass lens we use to look at small objects. That lens gathers light and magnifies the image for us. The universe works the same way. Massive objects, like galaxies or galaxy clusters, can act as a gravitational lens, bending light from a distant object and making it appear to us in a different way. Gravitational lensing comes in several forms, depending on the position, mass, and alignment of the lens and the light source. Weak lensing happens when the bending of light is subtle, causing the background galaxy's image to be only slightly distorted. Astronomers use these tiny distortions to map out the distribution of dark matter in the universe. Strong lensing occurs when the bending of light is significant, creating images that are magnified, clearly distorted, or even creating multiple images of the same source. And this is where our topic today comes in, the Einstein ring. So, how does an Einstein ring form, and why is it so remarkable? An Einstein ring is the rarest and most beautiful form of strong gravitational lensing. It happens when three conditions align perfectly. First, a distant light source, usually a galaxy billions of light years away. Second, a gravitational lens, a massive object between the source and us, often a large galaxy or cluster closer to home. And third, perfect alignment, the source, the lens, and the observer, that's us, must be in a perfectly straight line. When these three conditions meet, light from that distant galaxy is bent all the way around the gravitational lens, making the image of that galaxy appear as a perfect ring surrounding the lens object. Instead of seeing a small point of light or several distorted images, we see a magnificent circle of light. This is what makes an Einstein ring so special. It's the most perfect visual representation of the warping of space-time. The width of an Einstein ring depends on the mass of the lens and the distance between the three objects. The more massive the lens, the larger the ring. By studying the size and shape of these rings, scientists can calculate the mass of the lens, even if that object is invisible to us. And this is where the Einstein ring becomes a powerful tool for studying dark matter. Now, for one of the most exciting parts of this story, the role of Einstein rings in solving the two biggest puzzles of the universe, dark matter and dark energy. These two make up most of the cosmos, yet we can't see them, and we still don't fully understand their true nature. Dark matter is a mysterious substance that doesn't interact with light. It doesn't absorb, reflect, or emit it. So we can't see it directly, but we know it's there because we see its gravitational effects. Galaxies rotate too fast for the visible matter to explain. Galaxy clusters have more mass than they should, and the large-scale structure of the universe couldn't have formed without dark matter holding it all together. Einstein rings are an incredible tool for studying dark matter, because the bending of light that creates the ring isn't just caused by the visible matter in the lens galaxy, it's also caused by the mass of the dark matter within it. By carefully analyzing the shape and size of the ring, scientists can calculate the amount of dark matter hidden in the lens galaxy. This is one of the only ways we can weigh dark matter indirectly and understand how it's distributed across the universe. Then there's dark energy, a mystery just as deep. It's a mysterious energy believed to be causing the expansion of the universe to accelerate, which contradicts the old idea that gravity should be slowing it down. While Einstein rings don't detect dark energy directly, studying gravitational lensing as a whole, especially the distribution of galaxies and clusters across the vast universe, can provide insights into the expansion rate of the cosmos. It helps scientists build better models to explain the role of dark energy. In other words, Einstein rings are like a large window, allowing us to see the influence of the invisible and understand the fundamental building blocks of the universe we live in. In the world of astronomy, new discoveries always bring excitement, and recently, the Euclid Space Telescope from the European Space Agency made headlines around the world with the discovery of one of the most perfect and stunning Einstein rings ever found. This discovery doesn't just highlight Euclid's incredible capabilities, it reveals secrets of a galaxy we thought we already knew well. Euclid was launched into space on July 1, 2023, with a primary mission to explore the dark universe and create the largest 3D map of the cosmos. It observes billions of galaxies, up to 10 billion light-years away. During its early testing phase in September 2023, Bruno Altieri, a scientist at the Euclid Archive, noticed something unusual in a low-resolution image. When Euclid observed that area again with higher resolution, the image that appeared left everyone in awe. What Euclid found was a perfect Einstein ring surrounding the galaxy NGC 6505. This galaxy is only about 590 million light-years from Earth. In astronomical terms, that's very close. What's amazing is that NGC 6505 has been known to astronomers since 1884, but no one had ever noticed the Einstein ring surrounding it before. This shows the power and precision of Euclid's instruments, revealing new things even in places we thought we knew well. The ring seen around NGC 6505 is actually light from another galaxy much further away, about 442 billion light-years out. The light from this background galaxy was distorted by the gravity of NGC 6505, creating a beautiful and perfect ring. This distant source galaxy had never been observed before, and doesn't even have a name yet. This discovery is incredibly significant because it's the closest strong gravitational lens to Earth ever found, and its perfect alignment makes it a perfect natural laboratory for studying gravity, dark matter, and dark energy. Conor O'Riordan, from the Max Planck Institute for Astrophysics and lead author of the first scientific paper analyzing this ring, said, "All strong gravitational lenses are special because they are so rare and incredibly useful for science. This ring is especially special because it's so close to Earth, and the alignment makes it so beautiful. This discovery is a great sign for the Euclid mission, which is expected to find about 100,000 strong gravitational lenses over its lifetime. But finding such a stunning ring so close to home, so early in the mission, is truly extraordinary. Beyond the beauty and excitement of the discovery, Einstein rings are invaluable scientific tools. They allow astronomers to study phenomena and objects in the universe that wouldn't be possible any other way. First, studying the expansion of the universe. Einstein rings can be used as cosmic clocks. When light from a source reaches us through two different paths, one through the center of the lens and another through the outer edge, the two paths take different amounts of time. This time difference can be used to calculate the expansion rate of the universe, which is vital data for understanding the future of the cosmos. Second, seeing distant galaxies. Gravitational lensing acts like a massive natural telescope. It magnifies light from galaxies that are so far away and faint that we couldn't see them with normal telescopes. Einstein rings help astronomers study the formation and evolution of galaxies in the early universe, a time when the universe was young and very different from today. Third, mapping dark matter. As mentioned, analyzing the shape and size of an Einstein ring helps scientists map the distribution of dark matter in the lens galaxy. This is a key way to understand the nature of this mysterious substance, which makes up most of the mass in the universe. And fourth, searching for exoplanets. Although very rare, small gravitational lenses caused by single stars can create a phenomenon called microlensing. If the lens star has a planet orbiting it, it might cause tiny changes in the brightness of the magnified light, which can be used as a way to detect planets outside our solar system. Beyond its scientific importance, the Einstein ring offers deep philosophical insights, inviting us to reflect on the nature of reality and perception, seeing the invisible. Einstein rings help us see what is otherwise hidden, like dark matter. It reminds us that in our own lives, the most important things might not always be what we see with our naked eyes. Love, hope, dreams, or even fear are all invisible. Yet they influence our lives profoundly. Learning to see the invisible, or understanding what lies behind various phenomena, is a vital skill for living. Time travel. Light from distant galaxies travels for billions of light years before reaching Earth. When we look at an Einstein ring, we are looking into the distant past of the universe. It reminds us that we are just a small part of the vast history of the cosmos, and everything we see is the result of events that happened in the past. Realizing the greatness of time helps us value the present and understand that we are part of a story much larger than ourselves. An Einstein ring isn't just a beautiful illusion in the sky, it's a powerful tool that helps scientists unlock the mysteries of the universe. It's evidence of Albert Einstein's genius and a window that allows us to see the distant and the invisible. Imagine the darkest corner of space, not a darkness devoid of light, but a darkness born from something so immense it defies imagination, so vast that even light itself cannot escape. We are all familiar with the concept of black holes, but most black holes we've heard about are mere children compared to what we are about to unveil today. If a supermassive black hole like Sagittarius A star at the center of our Milky Way galaxy has a mass of about 4 million times that of our Sun, what would you call an object with a mass 10,000 times greater than that? Scientists call them ultramassive black holes, and among all the cosmic monsters, none are as terrifying and mysterious as TON 618. TON 618 isn't just the largest black hole we've ever discovered, it is the true cosmic devourer. It represents the very limit of our understanding of the universe, and a puzzle that challenges the laws of physics we know. In this podcast, we will dive into true darkness to understand what TON 618 is, how it was discovered, and what its existence tells us about the origin and fate of the universe. The story of TON 618 began with a surprisingly strange misunderstanding. In 1957, Mexican astronomers were surveying the sky to compile the Tonantzintla catalogue, a list of interesting astronomical objects. TON 618 was recorded as item number 618 on that list. But at the time, it was classified as merely a blue-white dwarf, or perhaps an unusually blue star. Just imagine, the most colossal object in the universe we've ever known was mistaken for a tiny dying star in our own galaxy. What a monumental misunderstanding. During the 1950s and 1960s, knowledge about objects called quasars was still in its infancy. Quasar is short for quasi-stellar radio source. They looked like small points of light, like stars. But in reality, they were the centers of distant galaxies, billions of light years away, shining with immense energy. The turning point came in 1970, when a radio survey was conducted in Bologna, Italy. This survey detected strong radio emissions from the location of TON 618, a clear signal that it was not an ordinary star, but a quasar. Astronomer Ulrich conducted observations with the McDonald Observatory and recorded the light spectrum of TON 618. This spectrum was the key to solving the mystery. Ulrich found that the spectral lines of TON 618 showed a significant redshift. Its redshift value was Z 2.219. In astronomy, such a high redshift value means that the object is moving away from us at a very high speed, and more importantly, it is very far from us. From cosmological calculations, a Z 2.1219 value tells us that TON 618 is at a light travel distance of 10.8 billion light years. But because the universe is continuously expanding, its actual current distance, or what is called the co-moving distance, of TON 618 is approximately 18.2 billion light years. This discovery confirmed that TON 618 was not a nearby white dwarf, but one of the brightest and most distant objects ever discovered at that time. And this was just the beginning of its incredible story. When we talk about black holes, we are talking about mass compressed to a point where its gravity severely distorts spacetime. And the size of a black hole is defined by something called the Schwarzschild radius, which is the boundary known as the event horizon, the point from which nothing, not even light, can escape. For TON 618, its mass was first estimated in 1979 by Ulrich and his colleagues. But a more precise measurement was made in 2019 using a technique to measure the velocity of gas orbiting the black hole. The results were astonishing. TON 618 has a mass of approximately 40.7 billion times the mass of the Sun, or 40.7 billion solar masses. This is a number difficult to imagine. To understand this number, we need to compare it with familiar objects. The Sun, 1 solar masses. Sagittarius A star, 4 million solar masses. The largest supermassive black hole in the Milky Way, 4 million solar masses. TON 618, 40.7 billion solar masses. TON 618 is not in the general category of supermassive black holes, but it is classified into a new type called ultramassive black hole, UMBH, which is a group of black holes with masses greater than 10 billion times that of the Sun. But its true size is even more astounding. The Schwarzschild radius of TON 618 is 1/300 astronomical units, or AU. 1 astronomical unit is the distance from Earth to the Sun. Imagine our solar system. The Sun is at the center. Mercury, Venus, Earth, Mars orbit nearby. Jupiter and Saturn are further out. Uranus and Neptune, the furthest planets, orbit at approximately 30 AU. The Schwarzschild radius of TON 618 is 40 times larger than the distance from the Sun to Neptune. If we were to place TON 618 in place of our Sun, its event horizon would extend far beyond the entire orbit of Neptune. This is a size beyond human comprehension. In terms of light distance, its radius is 0.0206 light years, or a diameter of approximately 390 billion kilometers. To visualize this more clearly, light takes about 8 minutes to travel from the Sun to Earth. Light takes about 4 hours to travel across our solar system. But light takes about 11 days to travel across the diameter of TON 618 from one side of the event horizon to the other. This is not just a black hole, but a solar system of darkness that is incomparably larger than our own solar system. The existence of a black hole of this size raises crucial questions. How did it grow so large? And why is it so incredibly massive? TON 618 is not famous just for the immense size of its black hole, but also because it is the brightest quasar we have ever discovered. What is a quasar? A quasar is a phenomenon that occurs when a supermassive black hole at the center of a galaxy is greedily feeding on matter. When gas and dust are pulled into a black hole, they don't fall in immediately, but instead swirl around the black hole at high speeds, forming an accretion disk. Friction within this disk heats the matter to temperatures of millions of degrees Celsius, releasing energy in the form of electromagnetic radiation, from radio waves to gamma rays, which means a quasar with exceptionally high luminosity. The luminosity of TON 618 is incredible. Its luminosity is approximately 1.4 times 10 to the 41st watts. This is equivalent to the brightness of our Sun 400 trillion times. Imagine you are looking for a tiny light bulb 18.2 billion light-years away, but that light bulb is so bright it can be seen from that immense distance. This is truly colossal energy. This immense brightness is a result of the frantic rate at which this 40.7 billion solar masses black hole devours matter. It is accreting gas and dust at a rate close to its maximum possible limit, also known as the Eddington limit. Furthermore, TON 618 is also a broad absorption line quasar, which means its spectrum shows very broad absorption lines caused by high-velocity gas ejected from the accretion disk and moving towards us. This outflow of matter is part of the process by which black holes regulate their own growth and may also affect star formation in its host galaxy. What's interesting is, even though TON 618 is so incredibly bright, we cannot see its host galaxy at all. The quasar's brightness completely obscures the light from all the stars in the galaxy it resides in, making that galaxy appear to be swallowed by the brilliant halo of light. In addition, TON 618 has been found to be located within a massive Lyman Alpha nebula, a colossal cloud of hydrogen gas extending for millions of light-years. This nebula may be the fuel source that has sustained the growth of this violent black hole and quasar since the early universe. TON 618 is therefore like a lighthouse of the early universe shining with unimaginable energy. It is clear evidence that these monsters of darkness are not merely destroyers, but also crucial mechanisms driving the evolution of the universe. To further illustrate the grandeur of TON 618, let's compare it with other largest black holes we know. The largest black holes discovered in the universe are divided into two main groups: TON 618 and Phoenix A star. TON 618, ultramassive black hole, or UMBH, 40.7 billion solar masses, 1 to 300 AU Schwarzschild radius, relatively high mass certainty, quasar actively devouring matter. Phoenix A star, ultramassive black hole, 100 billion solar masses, 1,900 AU Schwarzschild radius, lower mass certainty, relatively quiescent black hole at the center of a galaxy cluster. Although Phoenix A star has an estimated mass of up to 100 billion solar masses, the mass measurement of TON 618 has higher scientific precision, making TON 618 still the most massive confirmed black hole to date. The biggest mystery surrounding TON 618 is the growth problem. TON 618 is 10.8 billion light-years away from us, which means we are observing it in the past, when the universe was only about 3 billion years old. The fact that a black hole 40.7 billion times the mass of the Sun could form in such a short time after the Big Bang challenges current cosmological models. Scientists are trying to find answers to: were the black hole seeds in the early universe larger than expected? Did TON 618 grow continuously at a rate faster than the Eddington limit? Are there more violent and rapid black hole merger mechanisms than we understand? The study of TON 618 and other ultramassive black holes is therefore crucial to understanding how the large-scale structure of the universe formed, and the relationship between black holes and their host galaxies. We have journeyed through the story of its discovery, its astonishing size, and the immense energy of TON 618, but its true impact on space-time and on our existence is what is most thought-provoking. Large black holes like TON 618 have interesting effects on what are called tidal forces, which are forces caused by the difference in gravitational pull acting on an object at different distances. For smaller black holes, such as those formed from the collapse of stars, the tidal forces at the event horizon are so intense that they can tear an object falling into spaghetti-like strands, atom by atom, instantly. This phenomenon is called spaghettification. But for an ultramassive black hole like TON 618, the situation is entirely different, because its Schwarzschild radius is so large. The gradient of gravitational force at the event horizon is relatively small. What does this mean? If you were unlucky enough to fall into a small supermassive black hole, you would be torn to pieces before even crossing the event horizon. But if you fell into TON 618, you might feel nothing at all as you cross the event horizon. The tidal forces would be so weak that you could pass the point of no return with your body still intact. Of course, not long after that, you would approach the singularity, the central point of infinite density, and that would be the true end. But the journey through TON 618's event horizon is much smoother than that of smaller black holes. This is the fascinating paradox of the universe. The larger the monster, the gentler the entry into its domain. TON 618 is not just an astronomical object, but the largest physics laboratory in the universe. It helps scientists test Einstein's theory of general relativity in extreme conditions that cannot be replicated on Earth. The existence of TON 618 and other supermassive black holes prompts us to question the nature of reality and the limits of human understanding. It reflects our insignificance compared to the grandeur of the cosmos, but at the same time, it emphasizes the immense power of human intellect and curiosity, which can unravel the mysteries of the universe billions of light years away. These black holes are symbols of emptiness filled with unfathomable energy and mass. They remind us that, in the deepest darkness, there are still laws and phenomena more complex than we can imagine. The study of black holes is therefore not just the study of physics, but an exploration of the boundaries of knowledge and an acceptance of the mysteries that still exist. It teaches us humility and to open our minds to the limitless possibilities of the universe, that there are things we don't know and may never fully know. But the pursuit of knowledge is an endless journey, and every discovery, whether small or large, is a crucial step in understanding ourselves and our place in this vast universe. TON 618 is a reminder of the vastness and mystery of the cosmos. It shows that even in the early universe, there were mechanisms capable of creating structures so immense they defy our comprehension. Its existence forces us to re-evaluate our models of galaxy and black hole formation. It is evidence that there may be many other ultramassive black holes hidden in the darkness, awaiting discovery. As we look up at the night sky, TON 618 may appear as just a faint point of light, 18.2 billion light-years away, but in reality, it is a center of power, shining with the energy of 400 trillion suns and a gravitational abyss 40 times larger than our solar system. It is TON 618, the ultramassive black hole, the cosmic devourer, and a mystery still awaiting answers from humanity, and a priceless lesson that nature offers us about the grandeur, the mystery, and the beauty of the universe. Thank you for joining us on this journey into the realms of darkness and light today. If you are amazed by the story of TON 618 and wish to explore other mysteries of the universe, don't forget to subscribe to our channel. TON 618 is the brightest quasar and the most massive confirmed ultramassive black hole, 40.7 billion times the mass of the Sun. Its Schwarzschild radius is 40 times larger than Neptune's orbit. It is approximately 18.2 billion light-years away, and it's a mystery how it grew so rapidly in the early universe. Falling into TON 618 would be smoother than into a smaller black hole, due to weaker tidal forces at the event horizon. Studying supermassive black holes teaches us humility, and to open our minds to the limitless mysteries of the cosmos. Sometimes, in the quiet of the night, when our eyes gaze up at the dark sky, we see countless stars, sparkling like diamonds, scattered across a velvet canvas of deep black. We see the Milky Way, stretching out like a river of light, beautiful and mysterious. But have you ever wondered if behind all that splendor, there are questions lingering in your mind? Questions like, what lies hidden beyond all that brightness? There's something we can't see, but we can feel its presence. Something that constantly pulls and controls everything, making it revolve under an unseen power. Something that makes us feel that this universe isn't just a beautiful picture, but a mystery waiting to be discovered, and perhaps a mystery that we ourselves are a part of without even realizing it. Our galaxy, the Milky Way, is a vast home that we call the universe. It's an island of stars, made up of hundreds of billions of stars, gas, dust, and invisible dark matter. All of this comes together to form a colossal spiral structure, slowly rotating over billions of years. Just imagine its size. If light travels at 300,000 kilometers per second, it still takes over 100,000 years to travel from one end to the other end of the galaxy. And in that vastness, our Sun is just one of hundreds of billions of stars, orbiting far from the galactic center, about 26,000 light-years away. We, our Earth, our solar system, are moving along with the galaxy at an unimaginable speed, approximately 220 kilometers per second, or about 800,000 kilometers per hour, thousands of times faster than a bullet. Yet we don't feel this movement at all, because everything around us is moving along with us. But this immense movement isn't happening aimlessly. It's an orbit around some central point, an invisible center, but with immense gravitational pull that holds everything together, preventing it from scattering into the vast emptiness of space. And at that mysterious center, our story begins. The story of Sagittarius A star, or as scientists call it, the supermassive black hole, the invisible heart of our Milky Way galaxy. It's the point where density and gravity are at their most powerful, so much so that even light cannot escape. It's the center that dictates the fate of hundreds of billions of stars, including our Sun and ourselves. But before we dive into its mystery, let's first understand how scientists discovered the existence of this invisible thing and what made them so confident that at the center of our galaxy there is something immense and terrifying hidden away. The story of discovering Sagittarius A star didn't begin with seeing, but with listening. In the 1970s, scientists detected unusually strong radio signals coming from the center of our galaxy. Those signals were different from signals from ordinary stars. They indicated a source of energy that was powerful and mysterious, but radio waves didn't tell the whole story. What truly unlocked the mystery was observing the stars. Astronomers used powerful telescopes to watch the movement of stars near the galactic center. They found that many stars, especially the star S2, were orbiting at incredible speeds around an invisible central point. Just imagine, star S2 orbits that point at a speed of 5,000 kilometers per second, or about 18 million kilometers per hour, hundreds of times faster than Earth orbits the Sun. And most importantly, it orbits around an emptiness where there's nothing to see at all. Such rapid and violent movement indicates that at that invisible central point, there must be an enormous mass compressed into a tiny area, a mass sufficient to create immense gravity, to pull those stars to orbit under its power. And that is the clearest evidence, pointing to the existence of a supermassive black hole. Until 2022, the world witnessed the first image of Sagittarius A star. Not an image of the black hole itself, because nothing can be seen, but an image of its shadow, created by the event horizon, the boundary from which even light cannot escape. That image revealed a ring of light, formed by superheated gas, rotating at high speed around the dark emptiness at the center of our galaxy. It's an image that confirms that what was once just theory and inference has become a tangible reality, even if it's tangible to our eyes, through advanced technology, not by our own hands. And what if we, as tiny humans, were to get too close, or even fall into Sagittarius A star? What would happen? Just imagine. You're floating in the dark emptiness of space. Before you is a colossal dark spot that swallows everything, even light. You feel the gravitational pull increasing steadily. Your body begins to stretch out like spaghetti. Your head is pulled with more force than your feet because it's closer to the source of gravity. This is a phenomenon called spaghettification, the tearing apart of the body, caused by immense tidal forces. But before your body is torn into pieces, you might experience an even stranger phenomenon. Time, for you, will begin to slow down, slower, until it almost stops. Compared to an observer far away, you will see the universe outside, speeding up. Stars are born, die. Galaxies move in the blink of an eye, while you continue to float in a timeless loop at the event horizon. And once you cross that event horizon, nothing can ever return. You will be pulled into an endless darkness, to a point where our understanding of physics cannot yet comprehend, to a point where even time and space may no longer have meaning. It's a terrifying fate, but at the same time, it's a reminder of the immense power and limitless mystery of the universe. And it also leads us to a deeper question. If an entire galaxy, made up of hundreds of billions of stars, including our Sun and the Earth we live on, is orbiting around an invisible center that is so powerful and mysterious, then what about our lives? The lives of tiny humans living on this blue planet. What are we truly orbiting around? We may never realize that throughout our lives, we too are part of a system, revolving around something invisible, just like the hundreds of billions of stars in the galaxy, orbiting under the power of Sagittarius A star. Think about it. Every atom in our bodies was once part of a star that was born and died in the distant reaches of space. Those atoms have traveled through time and space to come together to form us, to form life, to form thoughts, to form feelings that are now listening to this story. We are the product of the universe, forged from stardust and immense energy. We are tiny fragments that reflect the grandeur of what surrounds us. And at the same time, we are the center of a small universe, called our own life. Sagittarius A star, the supermassive black hole, invisible, yet immensely powerful. It's the anchor that holds our galaxy together, preventing it from falling apart. It's the point of balance that allows everything to exist in the chaos of the universe. So in our lives, what is our Sagittarius A star? What is that invisible center that constantly pulls and determines the direction of our lives? Some people might be revolving around fear, the fear of failure, the fear of not being accepted, the fear of having to face reality. These fears can become immense gravitational forces that prevent us from moving forward, from changing, and keep us stuck in the same old orbit again and again. Some people might be revolving around dreams, grand dreams, of wanting to create, wanting to change the world, wanting to leave some mark behind. These dreams are the gravitational forces that push us to try, to learn, and to grow, to get as close as possible to that center of desire. And some people might be revolving around goals, clear goals, to succeed in their careers, to build a warm family, to find true happiness. These goals are the focal points that give our lives direction, meaning, and the power to move forward. No matter what we revolve around, those things are the invisible centers that determine the gravity and direction of our lives. Sometimes we might not even realize what we are being pulled by until we stop and try to consider what makes us move, what makes us us. Sagittarius A star isn't just a black hole, but it's a symbol of mystery, of immense power, and of an invisible center that holds everything together, just like our lives, full of mystery, full of hidden power, and full of invisible centers that determine our destiny. Perhaps understanding and accepting the existence of these invisible centers might be the first step to understanding ourselves better, understanding the universe better, and understanding the meaning of being alive in this vast expanse of space. And in that silence, perhaps the answer isn't in searching, but in accepting that some things, the greatest things, might be things we cannot see, but we can feel with our own hearts. What if, tomorrow, a black hole suddenly appeared in our solar system? Not a supermassive black hole, but a stellar mass black hole. Perhaps one with the mass of our Sun, or even just a few times its mass. What would be the first thing we'd notice? How would humanity react? And what would be the ultimate fate of our world? At first, we might not even notice it. Black holes are, by definition, invisible. They emit no light, reflect no light, and are incredibly difficult to detect directly. But their presence, their immense gravitational pull, would soon become undeniable. Astronomers, constantly monitoring the cosmos, would be the first to pick up on the subtle anomalies. Perhaps the orbits of distant planets like Neptune or Uranus would begin to show slight, inexplicable deviations. Or maybe the light from a distant star passing behind the black hole would momentarily dim or distort in a way that couldn't be explained by any known celestial body. This phenomenon, known as gravitational lensing, would be our first visual clue, a ghostly halo of warped starlight hinting at the unseen monster lurking in our cosmic backyard. News of this unprecedented discovery would spread like wildfire. Initial reactions would range from disbelief to panic. Scientists would scramble to confirm the data, running simulations and calculating the black hole's trajectory and potential impact on our solar system. Governments would convene emergency meetings trying to formulate a plan, any plan, to deal with this existential threat. The world would hold its breath, collectively grappling with a reality that was once confined to science fiction. As the second and third days unfold, the black hole's effects would become more pronounced. It would no longer be just numbers on a computer screen. It would be a phenomenon observable with the naked eye. The outer planets, especially Jupiter and Saturn, would begin to wobble in their orbits, like spinning tops losing momentum. The black hole's immense gravity would disrupt the delicate balance that had existed for billions of years, slowly but relentlessly tearing apart the structure of our solar system. Innumerable comets and asteroids, once peacefully orbiting in the Kuiper Belt and Oort cloud, would now be awakened. They would be drawn towards the black hole at high speeds, becoming a torrent of cosmic debris hurtling towards the heart of darkness. Some of them would be flung outwards in various directions, transforming into cosmic bullets ready to collide with any planet in their path. Our Earth would be no exception. And then the most astonishing phenomenon would begin to appear in the sky. The starlight behind the black hole would start to warp, as if viewed through a glass of water or through the shimmering heat rising from a road on a hot day. This phenomenon is called gravitational lensing. It occurs when the black hole's immense gravity bends the path of light, causing it to travel in curves instead of straight lines. The result would be images of stars overlapping, distorting, and stretching, forming a beautiful yet terrifying ring of light, known as an Einstein ring. It would be a reflection of the invisible power that was slowly consuming everything in its vicinity. The night sky, once a canvas of deep black adorned with millions of stars, would now transform into a surrealist painting. Stars would appear to dance around an invisible center, their light stretched, distorted, and coalescing into bizarre shapes. It would be a sight both beautiful and chilling, a vision that would make humanity realize that we were not merely observers, but participants in the grandest and most terrifying phenomenon in the history of the universe. As days 4 through 7 arrive, our world would begin to experience the true impact. It would no longer be just changes in the sky, but chaos unfolding on Earth. Powerful earthquakes would become more frequent in many regions. Giant tsunamis would crash onto coastlines. The weather would become severely erratic, with massive hurricanes forming like never before. Global temperatures would fluctuate wildly. Some areas would become scorching hot, making life unbearable, while others would freeze solid. It would be a warning that our world was being torn apart, distorted by a power beyond anything we had ever known. The moon, our nocturnal guardian, would also begin to feel the effects. The black hole's gravity would pull the moon out of its stable orbit. Even a slight change in the moon's position would have a catastrophic impact on Earth's oceans. Tides would become unprecedentedly strong, with colossal waves crashing onto land, eroding coastlines and engulfing cities. It would be a vision of a world slowly, yet relentlessly, being destroyed. Amidst the unfolding chaos, humanity would descend into panic. Fear would grip people's hearts. Some would desperately try to survive, others would form groups to seek refuge, while some would turn to religion, searching for answers and hope in a hopeless situation. Conspiracy theories would proliferate. Some would believe it was divine punishment, others an alien experiment. Still others would deny the grim reality before them. But no matter what, no matter who believed or disbelieved, our world would never be the same. The truth would be revealed, and it would change everything, forever. In the pervasive darkness, only the faint lights of cities would flicker. People would flee for their lives, screams, cries, and prayers echoing everywhere. It would be a scene of humanity confronting its end, an unavoidable end brought about by a power beyond anything we had ever known, a power that was consuming everything in its path. It would be the beginning of an unavoidable end. What would you do if you faced such a situation? Would you fight, or would you surrender? Would you find hope, or would you sink into despair? These are the questions the black hole would pose to us, questions no one ever thought they would have to answer until today, the day when everything was about to change, forever. As the second week and beyond unfold, the situation would deteriorate to a point of no return. Our Earth, once orbiting steadily around the Sun, would begin to drift out of its original orbit, like a ball flung from a string or being drawn ever closer to the black hole. The black hole's immense gravity would tear our world out of its former balance, pulling it into a dark abyss from which there would be no return. Temperatures on Earth would fluctuate to extreme levels. Some areas would become so hot that water would boil into vapor, while others would freeze solid in an instant. Day and night cycles would become distorted. Some days might have prolonged daylight, others might experience months of perpetual darkness, or perhaps there would be no more daylight at all, only an all-encompassing darkness, as if the entire world was being swallowed by emptiness. Global communication systems would collapse. Satellites orbiting Earth would be pulled and torn apart by the black hole's gravity. Phone signals, internet, radio, everything would go silent. The entire world would be cut off, people unable to communicate. Fear and isolation would grip people's hearts. It would be a vision of a world entering a dark age, an age without light, without sound, without even hope. In the pervasive darkness, there would only be the whistling wind and the groaning of a world being destroyed. People would desperately try to survive. Some would build underground shelters, others would try to travel to safer areas. But no matter where they went, no matter what they did, they would not be able to escape the creeping fate. It would be an unavoidable end, an end brought about by a power beyond anything we had ever known, a power that was consuming everything in its path. It would be the beginning of an unavoidable end. What would you do if you faced such a situation? Would you fight or would you surrender? Would you find hope or would you sink into despair? These are the questions the black hole would pose to us, questions no one ever thought they would have to answer, until today, the day when everything was about to change, forever. And then the final moments would arrive. The time when our Earth would be drawn close enough to the black hole to feel its terrifying power. It would be a point where nothing could resist, a point where the laws of physics we knew would begin to warp and break down. The first phenomenon to occur would be spaghettification, or being stretched like spaghetti. When any object, including our Earth, approaches a black hole closely enough, the gravitational force on the side closer to the black hole would be immensely stronger than on the side further away. This would cause the object to be stretched, as if pulled by immense forces from two directions. Our bodies, buildings, mountains, oceans, everything would be stretched into fragile strands before being torn into tiny pieces and swallowed into eternal darkness. At the same time, another astonishing phenomenon would occur. Time dilation, or the slowing down of time as one approaches a black hole. For those far away, they would see us moving slower and slower until we appeared to freeze in time. But for us, being pulled in, time would continue to pass normally. Only our seconds might become years for others, or perhaps an eternity. In that dark abyss, we might spend only a fleeting moment, but for those watching from outside, it could be millions of years, or perhaps never ending. It would be a journey to the ultimate end, a point where reality and imagination merge, a point where everything we knew would be destroyed and recreated in a form we could not comprehend. It would be a confrontation with emptiness, an emptiness filled with immense power, a power that could tear apart spacetime and consume everything. It would be an unavoidable end. How would you feel if you faced these final moments? Would you accept your fate, or would you fight until the very last second? Would you seek meaning, or would you sink into emptiness? These are the questions the black hole would pose to us. Questions no one ever thought they would have to answer until today, the day when everything was about to change forever. In the eternal darkness that the black hole leaves behind, or in the distorted moments we experience, we can't help but ask, what is this universe truly? What is the meaning of our existence? Are we merely specks of dust in a vast emptiness, or are we part of something greater, something we cannot comprehend? Confronting a power beyond anything we have ever known makes us realize our insignificance, the fragility of life, and the grandeur of a universe still full of mysteries and wonders waiting to be discovered. Perhaps the arrival of a black hole might not be an end, but a beginning. A beginning of awareness, a beginning of questioning, a beginning of searching for the true meaning of existence. In that darkness, we might find light, the light of wisdom, the light of understanding, the light of hope that will lead us to new discoveries, discoveries that will change our understanding of the universe and our existence forever. No matter what tomorrow brings, no matter if we still exist or not, one thing we will always remember is that we were once part of a grand story, a story written by a black hole, a story that made us realize the beauty, the terror, and the mystery of the universe. And in that memory, we will live on forever. In the darkness of a black hole, we find the light of meaning. Imagine this. You're sitting in the deepest darkness of the quietest night. Suddenly, an old radio, one you hadn't even turned on, whispers strange codes. That's exactly what happened to astronomers around the world just a few months ago. A mysterious signal sent directly from the depths of the cosmos. A signal that today's science still can't answer whether it's the sound of nature or a greeting from someone watching us from the shadows of the stars. Please don't scroll past. We'll dive into humanity's greatest secret, from signals that made the whole world hold its breath, to the latest discoveries in 2025 that might change our belief of being alone in the universe forever. Hello, everyone. Welcome to this journey beyond the horizon of events. Today, we're going to talk about one of the most chilling yet captivating topics, the mysterious signals from space. Humans have been trying to listen to the skies for decades. We've built colossal radio dishes. We've sent spacecraft far, far away, just to ask one question. Is anyone out there? But do you know? Sometimes, the answer that comes back is even scarier than silence. In the world of radio astronomy, we often encounter interference, whether it's from satellites, microwaves in the kitchen, or even from pulsars, which are neutron stars spinning rapidly. These pulsars are like cosmic lighthouses. They spin at incredible speeds, emitting radiation pulses more precise than atomic clocks. When scientists first discovered them, they even nicknamed these signals LGM-1, short for little green men. But the signal we're talking about today, it's different. It has order, rhythm, and immense energy, so much so that the physics we currently have can barely explain it. We'll start at the beginning of a nightmare, or perhaps a hope for alien hunters, the signal dubbed the WOW signal. Back on the night of August 15, 1977, at the Big Ear Radio Observatory in Ohio, the atmosphere was quiet, with only the sounds of machinery and old computers at work. Dr. Jerry Amon, a volunteer for the SETI project, was routinely examining data printed from the computer. The data were just numbers and letters indicating the intensity of radio signals detected by the dish. But then, his eyes caught a sequence of letters and numbers, 6EQUJ5. To most people, it might look like a random password. But for an astronomer, this was evidence of the strongest and narrowest narrowband radio signal ever detected. Each character represents the signal's strength, with numbers 1 to 9 indicating low strength, and letters AZ indicating progressively higher strength. The letter U in this code means the signal was 30 times stronger than typical cosmic background noise. Dr. Amon was so excited, he grabbed a red pen and circled the code, writing a short word next to it. Wow! That's where the name of the most famous signal in history comes from. What makes the wow signal so astonishing isn't just its strength, but its frequency. This signal was at 1420-405 MHz, a frequency close to the spectral line of hydrogen. Why hydrogen? Because hydrogen is the most abundant element in the universe. Scientists believe that if intelligent extraterrestrial life wanted to send a message to someone in the universe, they would choose this frequency because it's the most universal language in the cosmos, like tuning a radio to a popular station everyone knows. But the real mystery is, after those 72 seconds, the signal vanished as if it had never happened. Why 72 seconds? That's due to the operating characteristics of the Big Ear radio dish. It was designed to sweep the sky as the Earth rotated, and the point from which this signal originated would only be in the dish's view for a maximum of 72 seconds, which means the signal might still be transmitting, but we just rotated away from it. We tried pointing the dish back to the same spot in the constellation Sagittarius, again and again, for decades, but silence was the only reply. Until 2024 and 2025, new theories emerged. Some scientists proposed that the wow signal might not have come from aliens, but could have been caused by an event called a magnetoflare, or an explosion of a neutron star with an extremely strong magnetic field. Or, even more interestingly, the theory suggests it might have been caused by a hydrogen cloud, coincidentally amplifying a signal from a distant source, like a magnifying glass focusing sunlight. This phenomenon is called a maser, which is the amplification of microwave signals by stimulated emission of radiation. But whatever the truth may be, the wow signal left a scar in the scientific community. It reminds us that the universe is vaster than we can imagine, and sometimes we might just be lucky to hear a whisper from the darkness just once. If you thought the wow signal was scary, listen to the story of the latest discovery, which just happened on March 15th, 2024. On that day, China's new advanced space telescope called Einstein Probe, a collaboration between China, Europe, and the Max Planck Institute, detected an extremely powerful and unusual X-ray burst, unlike anything seen before. Scientists coded it as EP240408A. This signal didn't just flash and disappear like the wow signal, but it glowed brightly in the X-ray spectrum for 10 days. At first, everyone thought it was a typical stellar explosion, or what's called a supernova, which is the magnificent death of a massive star. But there was something unusual. The speed at which the signal faded and the characteristics of the energy emitted indicated an event called a tidal disruption event, or simply TDE. Imagine this: a star, which might have orbiting planets like our Earth, accidentally gets too close to a black hole. The immense gravitational pull of the black hole starts to tug more strongly on the side closer to it than the side farther away, until the entire star is ripped apart into pieces, like spaghettification. The remnants of the torn star orbit the black hole at high speed, generating immense heat that emits X-rays, and sometimes this enormous energy is released in the form of a jet, blasting through space at nearly the speed of light. But astronomers say EP2404 8A is even more special, because the black hole acting as the executioner this time might be an intermediate mass black hole, which is the rarest type of black hole. It has a mass hundreds to thousands of times greater than our Sun, but less than the supermassive black holes at the center of galaxies. What's interesting is, this signal faded much faster than theoretical predictions. Typically, TDEs take months or even years to fade, but EP240408A vanished in just 10 days, leading some scientists to question, could what we're seeing not be the natural death of a star? It's been observed that the signal pattern is too orderly, almost as if someone is using the energy from a black hole to send signals across galaxies. Or perhaps it's a high-level technological experiment by a civilization far more advanced than us. Although most conclusions still lean towards natural phenomena, EP240408A has opened a new door, showing us that in the dark corners of the universe, there are still monsters we don't know, and they might be sending us a warning. Now, let's move a little closer to home, not from a distant galaxy, but a signal coming from space junk, orbiting our own Earth. This is the story of NASA's IMAGE satellite, launched in 2000 to study Earth's magnetosphere and the magnetic field that protects us from solar winds. Everything seemed normal until December 18, 2005, when this satellite suddenly went silent. No data transmission, no response to commands. Scientists tried to recover the system for months, sending reset commands and using telescopes to search for it, but without success. Eventually, NASA declared the IMAGE satellite dead, assuming a primary power system failure. It became just a cold, lifeless chunk of metal, drifting aimlessly in space for over 13 years, amidst tens of thousands of pieces of space debris. But then, in January 2018, Scott Tilley, a Canadian amateur astronomer who was using his home radio dish to search for signals from secret US government satellites, stumbled upon a familiar radio signal emanating from a position that should have been empty. When he analyzed the signal code, he was shocked because it was a signal from the IMAGE satellite. A machine that had been dead for 13 years suddenly came back to life and started sending data back to Earth as if nothing had happened. The data sent was still in the same format, as if it had just woken up from a long sleep. The question is, how did it happen? The most plausible theory is an electrical short circuit, or that it was hit by a cosmic ray, causing the frozen computer system to reboot itself, like a home computer that freezes and then suddenly starts working again on its own. But that was just the beginning of the strangeness. Because in 2024 and 2025, there were reports from satellite monitoring groups that the signal from the IMAGE satellite began to show anomalies. The data sent back was no longer scientific data, but a series of numbers that looked like coordinates, pointing to a specific empty spot in space. Some scientists began to propose a theory that sounds like science fiction. Could this dead satellite have been interfered with by something that used our old machinery as a tool for communication, because it's easier than creating a new signal itself? Think about it. If you were an alien wanting to contact humans without causing panic, sending signals through a human-made satellite would be quite a clever way, wouldn't it? It's like someone secretly using a mobile phone you lost a long time ago to send you a message. Currently, NASA continues to monitor this signal closely, even though they say it's just a software glitch. But for those who are listening, the call from this dead satellite sounds like a whisper from the spirit world, warning us to look at what lies beyond the darkness. Now, we come to the most exciting story, and perhaps the clearest evidence of the existence of something beyond our Earth. In 2025, the Atlas Sky Survey System, which stands for Asteroid Terrestrial Impact Last Alert System, detected a fast-moving object entering our solar system with a strange trajectory. Scientists named it 3I Atlas. The letter I stands for interstellar, meaning it's an object from outside our solar system. It traveled across the void between stars for millions of years before visiting our home. It's the third object after Oumuamua and Comet Borisov. But what makes 3I Atlas different is that it didn't arrive silently like its predecessors. Several radio observatories worldwide, including large radio dishes in Australia, detected pulsating signals continuously emanating from this object. The signal's frequency changed with its rotation, as if it were scanning or sending some data back to where it came from. Scientists calmly tried to explain that it might just be a space rock, with a high composition of metallic minerals and semiconductors, and when it passes through the sun's strong magnetic field, it undergoes electromagnetic induction and naturally emits radio waves. But do you know, there's a group of independent researchers and signal engineers who analyzed that signal using artificial intelligence. They found something astonishing. The rhythm of the signal was too complex to be a natural phenomenon. It had a pattern similar to a mathematical code, composed of binary numbers. Even more astonishing, when 3I Atlas approached Earth most closely, the signal's frequency changed to the same band humans use for satellite communication, and there was a signal that looked like a response to radio waves emitted from Earth. Is this a coincidence or an intentional tuning for us to hear? Imagine this. If 3I Atlas isn't a rock, but an autonomous probe, sent from a civilization thousands of light years away to act as a sensor, detecting signs of life. When it found us, it began sending signals back to report. Although 3I Atlas is now moving away from our solar system and slowly fading into the darkness, it has left us with a big question. Was what just passed us by a strange space rock, or a reconnaissance drone from another civilization that briefly visited us before departing forever? Before we conclude our conversation today, there's one more signal that was just recorded on March 16th, 2025. That is FRB 2025-00316A. FRB stands for Fast Radio Burst, or a rapid burst of radio waves. This signal traveled from galaxy NGC 4141, which is 130 million light-years away from us. That means what we just heard was an event that occurred back when dinosaurs still roamed the Earth. Imagine the energy, released in just a fraction of a second, yet it's billions of times brighter than the entire Sun. The energy an FRB releases in 1 millisecond is equivalent to the energy the Sun releases in an entire year. What makes FRB 2025-00316A interesting is that it's a repeating FRB. It didn't just burst and disappear, but it emitted signals in cycles, every 16 days, with each cycle having a precise signal length. This regularity has led scientists to suspect that its source might not just be an astronomical phenomenon, like colliding neutron stars, but could be a megastructure, such as a Dyson sphere, using immense energy for some purpose. We might be listening to the engine of a Type 2 or 3 civilization, according to the Kardashev scale, which is a civilization capable of controlling the energy of an entire galaxy. They might be using these radio waves to propel massive spacecraft like light sails to travel across the universe. Finally, when we look back at all the signals we've discussed, from the mysterious wow signal to the call from the dead satellite, we might still not have a clear answer to, are they real, or are these signals just a coincidence of nature? But one thing is clear: humans never stop listening. Our attempt to decode signals from the stars isn't just about science, but it's about hope. We hope that in this vast and cold universe, we are not alone. We hope that the meaning of our existence will be recognized by someone. Perhaps these mysterious signals weren't sent for us to understand, but for us to realize. Realize that we are just a tiny speck in an ocean of stars, and the silence of space doesn't mean no one is there, but it might mean we are still just children, learning to listen to the sound of the waves before daring to sail into the true ocean. Silence doesn't mean emptiness, but it's a space waiting for us to fill with understanding. And you, if one day a signal reaches you, would you choose to reply, or would you choose to remain silent? Comment and let us know, and don't forget to subscribe to journey with us into the next secret. Imagine for a moment in the vast, silent darkness of space, where countless stars twinkle like distant diamonds. There is a world that hides incredible secrets and extremes that are almost impossible to grasp. You are standing on a rugged, ancient surface, scarred by countless craters from eons ago. The sky above is pitch black, even in the middle of the day, because there is no atmosphere to scatter the light. On one side of your body, you are being scorched by the intense, unforgiving glare of the sun. It's a heat so fierce it could melt the strongest metals. Every inch of your skin stings, as if caught in a blazing fire. But at the same time, on the other side of your body, a bone-chilling cold takes hold. It's a freezing void where everything stands still, where molecules almost stop moving entirely. And the most terrifying part? There is nowhere to run, no middle ground, no place to find relief from these two brutal extremes. This is Mercury, the planet closest to the Sun, yet a world defined by mystery and contradiction. It is the hottest and the coldest, all at once. It is a lesson from the universe, a journey to the very limits of nature that reflects back on our own lives. It reminds us that sometimes extremes are simply an unavoidable part of the journey. If you were to look from afar through a powerful telescope, Mercury might seem like nothing more than a tiny grey dot racing quickly around the Sun. It looks quiet, ordinary, lacking the majestic rings of Saturn or the vibrant colours of Mars. But beneath that simple exterior, Mercury hides a reality that is both fascinating and harsh beyond imagination. It is the smallest planet in our solar system, only about a third the size of Earth, even smaller than some moons. But don't let its size fool you. It is the second densest planet we know, which tells us it has a massive, heavy iron core. Being the Sun's closest neighbour, at an average distance of only 58 million kilometres, it faces an overwhelming onslaught of solar energy. The sunlight hitting Mercury is 7 times more intense than what we feel on Earth. Imagine the hottest summer day you've ever experienced, and then multiply that intensity many times over. That is Mercury's daily reality. What truly sets Mercury apart is that it has almost no atmosphere at all. Instead of a thick blanket of nitrogen and oxygen like we have on Earth, Mercury has only a thin, fragile layer called an exosphere. It's made of atoms like hydrogen, helium and sodium, kicked up from the surface by solar winds. This thin layer can't act as a shield or a warm blanket to regulate the temperature or protect the surface from radiation and meteorites. Unlike our Earth, which filters out harmful rays and burns up space rocks before they hit the ground, Mercury stands naked, completely unprotected. Everything on its surface is exposed to the raw power of the cosmos. It is a world where nature shows us its most magnificent and its most brutal. face. The lack of a real atmosphere doesn't just mean there's no air to breathe. It means there is no way to control the temperature. Imagine a house with no roof, no walls, and no insulation. When the sun shines, the heat pours in directly, scorching everything in its path. And the moment the sun sets, all that heat escapes instantly into the void of space. Nothing stays behind to keep the world warm. This happens every single day and every single night. On Mercury, there is no wind, no clouds, no rain. There is only a haunting, heavy silence. A silence so deep you might even hear your own heartbeat if you could stand there. During the day, temperatures can soar to 430 degrees Celsius. That's hot enough to melt lead. The solid rock beneath your feet could practically turn into a lake of molten metal. The sunlight doesn't feel warm. It feels like destruction, a relentless, merciless burn. But as the long night begins, a night that lasts for many Earth days, the temperature plummets. It drops all the way down to minus 180 degrees Celsius. That is far colder than the North Pole. It's so cold that the very gases in the exosphere might freeze solid. Everything becomes brittle, fragile, ready to shatter. This 600-degree swing is the most extreme temperature change in the entire solar system. It's not just hot or cold, it is extreme, with no safety net, no middle ground to rest. This is the harsh truth of Mercury, a lonely world facing the violence of the universe all on its own. It teaches us that an atmosphere isn't just about breathing. It's what makes our Earth an oasis of life in a vast and unforgiving universe. Imagine if you could stand on Mercury without a spacesuit. You open your eyes, and the first thing you feel is the blinding glare. The sun appears 2.5 times larger than it does on Earth, burning directly into your vision. You would feel the heat radiating through every part of you, not just on your skin, but deep in your bones, in every cell. Your skin would blister almost instantly. Without protection, the heat would build up until it's unbearable. And because there is no air, you wouldn't be able to breathe. Your lungs would ache for oxygen, but find only emptiness. Everything would be silent, just the crushing heat and a profound sense of isolation. You might look for shade behind a crater or a large rock, but even in the shadows, the heat trapped in the ground would still radiate outward. There is no escape. You would feel like you were trapped in a giant oven with no way out. But if you turned away from the sun and stepped into the darkness, everything would change in an instant. The scorching heat would vanish, replaced by a cold that bites deep into your soul. It's a cold so intense it would turn you to stone. Your muscles would freeze, your movements would slow down until you felt like a statue of ice. The rocks around you would crack and groan under the stress of the sudden temperature drop. You would see your shadow stretching out into an endless, starless dark, just the freezing void and a terrifying silence, making you feel like the last living thing in the universe. This is the experience of Mercury, a test of endurance in a place beyond human imagination. On Mercury, time moves to a different rhythm. It's not just about how fast it orbits, but the strange relationship between its rotation and its journey around the sun. One single day on Mercury, from one sunrise to the next, takes 176 Earth days. Imagine waiting that long for the sun to rise again. In that time, Mercury has already circled the sun twice. This is a spin-orbit resonance, a 3:2 ratio, where it rotates 3 times for every 2 orbits it completes. This creates a phenomenon called a double sunrise in some parts of the planet. Imagine the sun rising over the horizon, scorching the land, and then suddenly, it sets again for a brief moment, as if night is returning. But then, it rises a second time, continuing its slow crawl across the sky. It's a sight that challenges everything we know. It's a world where the rules of time are flipped upside down. Our sense of time is defined by the Earth's rotation, by the rhythm of day and night, and the changing seasons. But on Mercury, those rules don't apply. It reminds us that what we call normal is just what we are used to. It's just one perspective from our tiny blue world. The universe is full of wonders that challenge our understanding. The strangeness of time on Mercury isn't just a scientific fact. It's an invitation to open our minds, to accept that reality isn't one size fits all. Mercury whispers to us, don't limit yourself to your old ways of thinking, because there is so much more to discover. Mercury is a world of extremes, with no middle ground. And sometimes, our lives feel the same way. We've all had moments where we felt like we were standing on Mercury, moments where our emotions soar to the highest peaks or crash to the lowest depths. The overwhelming joy, the burning passion, the bright light of success that makes us feel like we're floating on clouds, or the crushing sadness, the dark disappointment, the failure that makes us feel frozen and numb. In those moments, we look for a safe space, a middle ground where we can rest and hide from the extremes. We long for a life that is smooth, a steady happiness without pain or challenge. We try to build safe zones in our relationships, our careers, even our thoughts, just to avoid the volatility of life. But often, we find there is no middle ground, no safe zone to hide in. Just like Mercury has no atmosphere to protect it, life sometimes leaves us exposed. We have to stand in the heat of our problems, or the cold of our loneliness, without any shield. And that is the lesson Mercury teaches us. Accepting the extremes might be the only way to move through them. It shows us that trying to run away from the extremes isn't always the answer. Perhaps the key is learning to live within them, to understand that joy and sorrow, success and failure are all part of the same path. They are things to be embraced, not rejected. Just as an explorer learns to survive in harsh environments, we must learn to survive our own emotional shifts and find meaning in those extremes. There are times in life when you might feel like you're standing on Mercury, burning with the pressure, the expectations, the anger that scorches your heart, or freezing with the loneliness, the emptiness, the despair that bites at your soul. In those moments, you might be searching for a middle ground that doesn't exist. We try to find balance, a perfect just right in everything. We believe a good life is a flat line, without the ups and downs. We avoid pain and cling to happiness, but in reality, life isn't always like that. Maybe accepting that some things have no middle ground is the first step toward growing. Mercury teaches us that extremes are a part of nature, and so are they a part of us. Joy and sorrow, love and loss, they are two sides of the same coin. You can't have one without the other. To try and have only one side is to deny the reality of being alive. Maybe we don't need to find a perfect place. We just need to learn how to breathe in the heat of our struggles and how to find warmth in the cold of our isolation. We need to understand that being in an extreme doesn't mean something is wrong. It's just part of the experience, the thing that gives our lives depth and mystery. Like Mercury, even in its extremes, it is still beautiful. It is a vital part of this vast universe. It reminds us that even in the deepest darkness, there is light, and even in the coldest void, there is hope waiting to be found. In the vast expanse of the cosmos, amidst the darkness and the infinite mysteries, millions of stars twinkle in the distance, But among all that celestial beauty, one star stands out, shining with a brilliance so intense it looks like a finely cut diamond set against the black velvet of the night sky. We call her Venus. To some, she is the evening star, appearing just as the sun sets, and to others, the morning star, herald of the dawn. In ancient civilizations, she was the embodiment of Venus, the goddess of love, beauty and fertility, a symbol of allure and captivating mystery. But have you ever stopped to wonder, beneath that radiant glow and those soft cream-colored clouds, Venus hides a terrifying secret. The beauty we see from afar is, in reality, the harshest environment in our solar system, a scorching, merciless hellscape. Today, we're going to journey across space and travel back through time to explore the past and dive into the present of this planet. We'll search for the answer to what happened to her. How did the most beautiful planet in the sky become a hell that no living thing could ever endure? Venus is often called Earth's twin. That's because she's remarkably similar to our home in terms of size and mass. Her diameter is about 1,204 kilometers, while Earth's is 12,742, a very small difference. In theory, she should have had the same potential to support life as Earth does. When viewed from space, Venus is wrapped in a thick, pale shroud of clouds that reflect sunlight brilliantly. This is why she's the brightest object in our sky, second only to the moon. These clouds look like a veil of pure white silk, hiding a grim reality beneath. But this physical similarity is just an illusion. If we could step onto the surface of Venus, we would find a world that is nothing like our home. Imagine an atmosphere so dense it would crush you, temperatures hot enough to melt metal, and rain that falls as sulfuric acid. This is the reality of Venus today. The question is, why did a planet so similar to ours, one that should have been hospitable to life, take such a drastically different path? To understand how this catastrophe began, we have to look back at her past. NASA scientists once proposed a fascinating theory, billions of years ago. Venus might not have looked the way she does today. Early climate models suggest that ancient Venus could have had deep oceans covering her surface, blue skies, and temperatures cool enough for life to thrive, much like the early Earth. Imagine that while life was just beginning to evolve on Earth, Venus might have been a warm, welcoming home. She had water, the essential ingredient for life, and an atmosphere that could have supported small organisms for as long as 2 billion years. That's a vast stretch of time, long enough for life to have made significant progress. However, this theory has been challenged by newer research. Some studies from 2024 suggest that Venus may never have had liquid water at all, or if she did, it was very little and for a very short time. They propose that Venus might have been born to be hell from the very start. Being closer to the sun, she received more energy and might have been too hot from the moment she formed for water to ever condense into oceans. Regardless of her true past, most scientists agree there was a major turning point that sent Venus down a completely different path from Earth. One key factor is her incredibly slow rotation. A single day on Venus lasts 243 Earth days, which is actually longer than her year, which is only 225 Earth days. This sluggish rotation might have thrown her cooling system out of balance, causing heat to build up on the side facing the sun for long periods. And that was the beginning of a disaster known as the runaway greenhouse effect. Picture this, back when Venus still had some water. As the temperatures began to rise, perhaps due to changes in solar intensity or geological activity, the oceans started to evaporate. That water vapor is an incredibly powerful greenhouse gas. It trapped the sun's heat within the atmosphere, preventing it from escaping back into space, which caused the temperature to climb even higher. As it got hotter, more water evaporated, creating more vapor, which trapped even more heat. It became an endless cycle, an uncontrollable chain reaction. While the water vapor was trapping heat, ultraviolet radiation from the sun began breaking down the water molecules in the atmosphere, stripping away the hydrogen. Because it's so light, the hydrogen escaped into space, leaving behind oxygen to react with other elements on the planet. At the same time, carbon dioxide was being released from the rocks and volcanic eruptions, building up into a thick, heavy atmosphere. Today, carbon dioxide makes up 96.5% of her entire atmosphere. This dense gas acts like a giant blanket wrapped around the planet, trapping heat with extreme efficiency. The heat building up inside simply has no way out. This was the end of Venus as a potentially habitable world, and the beginning of the era of cruelty we see today. The current state of Venus is like something out of a nightmare, a true inferno in our solar system. Surface temperatures reach a staggering 460 degrees Celsius. That's hotter than the surface of Mercury. Even though Mercury is much closer to the Sun, it's hot enough to melt lead, tin, or even zinc with ease. If you stood on the surface of Venus, you would be incinerated instantly. Then there's the atmospheric pressure, 92 times greater than Earth's. Imagine diving nearly a kilometer under the ocean. That's the kind of crushing force we're talking about. Probes sent there have to be specially designed, and even then, most only survive for a few hours before being crushed or melted by the overwhelming heat and pressure. Up in the sky, those beautiful cream-colored clouds we see from Earth are actually thick banks of sulfuric acid. The rain that falls is highly corrosive, but because the surface is so intensely hot, the rain evaporates before it ever hits the ground, a phenomenon called virga. This leaves the surface of Venus bone dry and covered in volcanic rock. The winds on Venus are just as strange. About 60 to 70 kilometers above the surface, the upper atmosphere moves at incredible speeds in a process called superrotation. It circles the entire planet in just 4 Earth days. That's 60 times faster than the planet itself rotates. But down at the surface, even though the wind moves slowly, the atmosphere is so dense it feels like moving through a thick liquid, strong enough to roll small rocks across the ground. Humanity has spent decades trying to understand this planet. The Soviet Union's Venera program was a true pioneer, sending over 20 spacecraft to Venus. They were the first nation to successfully land a craft on another planet. In 1970, Venera 7 became the first to land and transmit data back, though it only survived for 23 minutes. In 1975, Venera 9 sent back the first black and white photos from the surface, revealing a landscape of sharp, jagged rocks. And in 1982, Venera 13 sent the first color images and even recorded the sound of the Venusian wind. It lasted 127 minutes, a record that still stands for the longest survival on the surface. Later, NASA's Magellan mission used radar to map 98% of the surface, revealing a staggering number of volcanoes, over 1,600 major ones, more than any other planet in the solar system. 90% of the surface is basaltic rock, and 65% is covered in lava plains, showing that volcanoes played a massive role in shaping the world. Recent discoveries from 2023 and 2024, using that same Magellan data, have found evidence that volcanoes on Venus are still active today. Sif Mons, for example, shows changes on its surface caused by recent lava eruptions. Venus doesn't have plate tectonics like Earth. Instead, she uses a process called resurfacing, massive volcanic eruptions across the entire planet, to release internal heat, completely renewing the surface all at once. This likely happens every few 100 million years. Despite being similar in size to Earth, Venus lacks an internal magnetic field. This is likely because her core isn't moving in a way that creates a dynamo, or perhaps she rotates too slowly. Without a magnetic field, The solar wind, a stream of charged particles from the sun, can easily strip away the upper layers of her atmosphere. This is one of the main reasons why Venus lost almost all of her water. The story of Venus isn't just a tale of a distant planet, it's a warning sent directly to us. Our world today is facing global warming, driven by the buildup of carbon dioxide and other greenhouse gases. Human activities, especially the burning of fossil fuels, have released these gases into our atmosphere in massive quantities. While our situation isn't as extreme as Venus yet, she serves as a clear lesson, a reflection of the ultimate endpoint. She shows us what happens if we allow the balance of our atmosphere to be destroyed, beyond the point of no return. Venus is a reminder that a planet with the potential for life can become a world without hope if the natural balance is shattered. The story of Venus makes you wonder. If the most beautiful thing can become the most dangerous, is there anything like that in your own life? Perhaps a fleeting beauty hides a hidden danger. Perhaps the things we overlook are the keys to maintaining balance. And perhaps, by learning from the past of another world, we can realize the true value of the home we have and protect this beautiful blue planet of ours forever. Before you close your eyes tonight, think about what we can do to preserve this fragile balance. Have you ever dreamed of waking up on the red planet, looking out your window to see a dusty pink sky and the tallest volcano in the entire solar system? But here's what Elon Musk or NASA might not tell you up front. The moment you step off that spacecraft, the blood in your veins will start to boil, your lungs will struggle to pull air that isn't there, and cosmic radiation will begin tearing through your DNA every single second. Welcome to Mars. It's one of the most beautiful places you'll ever see, but it's also ready to kill you in every way imaginable. Today, we're diving deep into the reality of life on the red planet, and just how brutal it would actually be. Why are we so determined to go there? It's hundreds of millions of kilometers away. The weather is harsher than the South Pole, and there isn't a single breath of oxygen to be found. The short answer is survival. Many leading scientists believe Mars is humanity's best backup plan, a safety net if Earth ever faces a crisis we can't overcome. But there's a massive difference between existing and living. In the movie The Martian, we saw Mark Watney grow potatoes and survive using his wits. But that's just a movie. In real life, the first obstacle isn't farming. It's the journey itself, a journey that could take your life before you even arrive. Today, we're taking that journey together. From the moment the rocket leaves Earth, through 7 months in the dark void of space, to the second your boots touch the red dust. We'll explore what it's like to live in a glass prison where a single mistake, even a tiny one, could be your last. Imagine being trapped in a cramped room the size of a public restroom, with 4 or 5 strangers, for 7 to 9 months straight. No windows to let in a breeze, no fresh food, and most importantly, no gravity. During that first week, you'll suffer from space adaptation syndrome. Your body won't know which way is up or down. You'll feel nauseous, you'll vomit, and you'll be dizzy constantly. In this weightless environment, the human body starts to break down fast. Your muscles will wither away from lack of use. Your bones will lose calcium, becoming as brittle as someone with severe osteoporosis. Astronauts have to exercise for hours every day. But even then, it only slows the decline. And that's not even the scariest part. The real danger is radiation. On the way to Mars, your ship will be bombarded by high-energy particles from the sun and cosmic rays from deep space. Even thick walls can't stop them all. They'll pass through your body like invisible bullets, damaging your cells and skyrocketing your risk of cancer. Then there's your mental health. watching Earth get smaller and smaller until it's just a pale blue dot, and then finally vanishing into the darkness. It creates a feeling known as the Earth out of view phenomenon. It's the deepest isolation a human being can ever experience. And remember, that's just the trip there. Once you arrive, you might think the hard part is over. But the truth is, it's only just beginning. Mars is a dead planet, and it will try to kill you every second you let your guard down. First, there's the air. The Martian atmosphere is 95% carbon dioxide and only 0.1% oxygen. But even worse than the lack of oxygen is the air pressure. It's 100 times lower than on Earth, well below what's known as the Armstrong limit. If you took off your helmet, the fluids in your body, your saliva, your tears, and your blood would literally start to boil. Because the pressure is so low, the boiling point drops to your body temperature. You'd be gone in less than a minute. Then there's the cold. The average temperature on Mars is minus 62 degrees Celsius. On the coldest nights, it can drop to minus 125. That's far colder than anywhere on Earth. Without a perfect heating system, you'd become a block of ice in minutes. And we can't forget the dust. Martian dust isn't like the dust in your home. It's as fine as powder, and it carries a static charge. It sticks to everything, your suit, your solar panels, and most dangerously, it contains perchlorates. These are chemicals that are highly toxic to humans. If you breathe them in, or if they contaminate your food, your thyroid will be destroyed. Martian dust storms can last for months, blocking out the sun and plunging your power systems into a total crisis. So, how do we actually live there? The answer is, we have to build a bubble of life. Your home won't be anything like what you're used to. It'll be a habitat specifically designed to block radiation and maintain pressure. Most scientists suggest building underground, using the Martian soil as a shield against cosmic rays, or perhaps living in structures 3D printed from thick concrete. And what about food? Forget about a juicy steak or a fresh salad. Most of your meals will be powders or dehydrated food sent from Earth. If we want to grow our own food, we'll need high-tech greenhouses with strictly controlled environments, and every drop of water has to be recycled. Yes, that includes your sweat and your urine. The system filters it until it's perfectly clean, so you can drink it over and over again. Your daily routine will be governed by a strict schedule. You'll have to exercise at least 2 hours a day to fight the effects of low gravity. If you don't, your bones will become so fragile they could snap just from a minor fall. Life on Mars is a constant battle against boredom and paranoia. You'll check the air filters every day, monitor power levels every hour, because if the oxygen generator stops for just 10 minutes, it's the end for everyone in the habitat. You'll never feel a real breeze again. You'll never smell the Earth after it rains. Everything you breathe will be air that's been through a filter thousands of times. The most terrifying thing isn't what's outside. It's what's happening inside your own body. The gravity on Mars is only 38% of Earth's. This causes blood to flow more toward your upper body. Your face will swell, your nose will always feel stuffed, and most seriously, your eyes will start to fail. The increased pressure inside your skull pushes against the optic nerve. Many astronauts develop sudden farsightedness, and it can lead to permanent vision loss. And what if you get sick or injured? On Mars, there are no hospitals. If you get appendicitis, your teammates will have to perform the surgery themselves with limited tools and advice from Earth that takes 20 minutes to arrive. That's right. Radio signals take 20 minutes to travel each way. If you ask a doctor on Earth a question, by the time they receive it and send a reply, nearly 40 minutes have passed. In an emergency, those 40 minutes are the difference between life and death. But the greatest cruelty might not be physical. It's the mental toll. The realization that you can't just go home. it starts to eat away at you. You'll miss everything about Earth, even the little things that used to annoy you. Conflicts in a small group will become intense. There's nowhere to run. You have to see the same faces, eat together, and sleep in the next room for years. It's the most brutal psychological test in human history. After hearing all this, many of you are probably shaking your heads, saying, "No way." But why? Why did hundreds of thousands of people sign up for the Mars One project, even though it was a one-way ticket? It's because the spirit of exploration is in our blood. We're willing to trade comfort and safety just to be the first to see something new. Mars might be brutal, but it's the inevitable next step. If we want the human race to survive for another 10,000 years, we have to learn to live in places that were never meant for us. Life on Mars won't be glamorous like in the movies. It'll be hard, it'll be risky, and it'll be the greatest sacrifice ever made. But in that brutality lies the beginning of a new chapter in history. A chapter that says, humans weren't born to stay only on Earth. What about you? If you had the chance to go, knowing just how brutal it would you still take it? Let us know in the comments. And don't forget to subscribe to explore the mysteries of the universe with us. In the vast expanse of space, where millions of stars twinkle and shimmer, like diamonds scattered across a velvet black canvas, amidst that boundless silence, a giant planet floats majestically. It is Jupiter, the largest planet in our solar system, with its orange and white swirling patterns like an intricate abstract painting. It rotates slowly, revealing its hidden power and mystery. And what if, for some reason beyond our control, you were drawn into its immense gravitational pull? How would you feel? How would your body react when faced with this unfathomable grandeur? Where would you fall? When would your journey end? And most importantly, would you find solid ground to stand on? These questions might sound like science fiction, but today I will take you on a deep dive into the heart of Jupiter to uncover answers that are both astonishing and thought-provoking about our own lives. Jupiter, or as we call it, the gas giant, is completely different from our Earth. Our Earth has solid ground for us to stand on: mountains, oceans, clear beginnings and endings. But for Jupiter, it's a giant ball composed mostly of gas. Imagine a colossal cloud, 1/300 times larger than Earth, and with a mass 2.5 times greater than all other planets in our solar system combined. That's Jupiter. Its primary components are hydrogen and helium, much like our own Sun, which are the lightest elements in the universe. And because of this composition, Jupiter has no solid surface for us to touch, no land for us to firmly stand on. It is a world without clear boundaries, merely a gathering of gases that become denser and denser as we journey deeper. Imagine standing on a cloud. You would feel softness, emptiness, and weightlessness. Jupiter is similar. It is an endless cloud, a vast ocean of gas beyond our imagination. If you were to fall into Jupiter, your journey would begin in its uppermost atmosphere, the troposphere. There, the air would be frigid, reaching 145 degrees Celsius, and the gases so thin they're almost non-existent. But as you plunge deeper, you would begin to notice increasingly astonishing and violent changes. You would pass through beautiful and complex cloud layers. The uppermost clouds are pure white ammonia clouds, reflecting sunlight, making them sparkle. Below that are brownish-orange ammonium hydrosulfide clouds, which are responsible for the colored bands we see on Jupiter. And even deeper, there might be water ice clouds, similar to those on Earth. These clouds aren't static, you see. They are swept along by winds many times stronger than hurricanes on Earth. But this journey isn't just about beauty. The pressure would begin to increase immensely, and violent storms like the Great Red Spot, a massive swirling storm larger than our Earth, would rage around you. This storm isn't just a surface phenomenon, you know. Studies have shown it to be 300 to 500 kilometers deep, a storm that has persisted for centuries, demonstrating the immense energy driving this planet from within. And it's not just the Great Red Spot. Jupiter is also filled with incredibly powerful thunderstorms. Lightning on Jupiter is 100 to 10,000 times more powerful than lightning on Earth. Imagine flashes of brilliant violet light cutting through the dense dark clouds, the roaring sound of storms echoing in every direction. It's an experience that is both awe-inspiring and terrifying at the same time. Scientists have also discovered a phenomenon called mushballs, which are hailstones composed of ammonia and water ice. These hailstones form in the upper atmosphere, and as they grow heavier, they sink into deeper atmospheric layers, carrying ammonia with them. This helps explain the distribution of ammonia in Jupiter's atmosphere. This phenomenon reveals the complex and dynamic cycle of this gas giant. As you sink approximately 100 kilometers, sunlight can no longer penetrate. Everything would be pitch black. You would feel like you're plunging into a bottomless ocean. The pressure would continuously increase until your body could no longer withstand it, and the temperature would rise alarmingly due to the compression of gases. At this depth, the air would be so dense that you couldn't distinguish between gas and liquid. It's a state halfway between the two. You would no longer fall, as you would on Earth, but would begin to sink into an increasingly dense fluid, like sinking into thick, murky water. There's no clear end, no solid ground for you to rest on. This journey is a descent into endless depths, where the laws of physics we're familiar with on Earth begin to change. And as you go even deeper, at a depth of approximately 13,000 miles or about 21,000 kilometers, the pressure would be so immense, reaching 2 million bars, that hydrogen, which is normally a gas, would be compressed until it transforms into liquid metallic hydrogen. It's a colossal ocean of hydrogen that behaves like a metal, capable of conducting electricity, and is the source of Jupiter's powerful magnetic field. Jupiter's magnetic field is 20,000 times stronger than Earth's magnetic field. It creates a massive protective shield called the magnetosphere, extending millions of kilometers into space. This magnetic field protects Jupiter from solar winds, but at the same time it traps high-energy particles, creating extremely dangerous radiation belts around the planet. Your journey at this point would not only be about facing pressure and heat, but also radiation that could destroy all life in an instant. And what about Jupiter's core? Is it solid like our Earth's? Scientists once believed that Jupiter had a solid rocky core, but recent data from the Juno spacecraft has revealed an even more astonishing truth. It suggests that Jupiter's core might not be a distinct solid core as we once thought, but rather a fuzzy core, a mixture of rock, ice, and metallic hydrogen spread over a vast region. It doesn't have clear boundaries, but gradually blends into the surrounding liquid metallic hydrogen layer. At the center of Jupiter, temperatures could reach 35,000 degrees Celsius, which is hotter than the surface of the Sun. And the pressure is immense, reaching 45 million bars. No known life form could withstand such an environment. It is a hellish realm filled with energy and violence, where familiar matter is compressed until it possesses strange properties beyond our imagination. Imagine this. If a human were to actually fall into Jupiter, what would happen? This journey would be filled with unimaginable torment and despair. You would be incinerated by the dangerous radiation around Jupiter before even entering its atmosphere. These radiation belts are so intense they could destroy your body's cells in minutes. You would feel like you're burning from the inside out before even experiencing Jupiter's atmosphere. If you somehow survived the radiation, which is impossible in reality, you would face extreme cold in the upper atmosphere. Temperatures hundreds of degrees below freezing would instantly freeze your body, and hurricane-force winds exceeding 600 kilometers per hour would tear your body apart. You would be tossed uncontrollably amidst an endless storm. As you go deeper, the pressure would crush your body until it disintegrated. Bones would shatter, internal organs would be pulverized beyond recognition, and the rising temperatures would eventually vaporize you. Your body would transform from solid to liquid and gas, becoming part of Jupiter's dense clouds. If anything remained until the liquid metallic hydrogen layer, the extreme pressure and temperature would compress and break down the matter in your body into atoms. Your body would dissolve into a part of Jupiter's gases and liquids. Not even a trace would remain, not even a molecule that could remember once being human. It would be a complete disintegration, an engulfment by the immense natural world. So, no matter how hard you try, you can never stand on Jupiter, because there is no solid surface for us to step on. It is a world of constantly changing gases and liquids, a journey into endless depths, with no stable destination for us to reach. It is a state without stability, without clear boundaries, merely the existence of matter in extreme conditions. Dear listeners, the story of Jupiter makes me reflect on our own lives. It's not just a story of a distant planet, but a reflection of something profound within us. Sometimes in life, we feel like we're in a place where there's no ground to stand on. We face uncertainty, endless change. At times, we might feel like we're sinking into unknown depths, not knowing where we'll stop, not knowing if there will be a clear end. This feeling of being adrift can be frightening, but it's also part of life's journey. We try to control things around us, try to create stability, try to find ground for us to stand on. But sometimes, the things we try to control are too vast and complex for us to understand, like the pressure and storms on Jupiter. All we can do is accept them and learn to live with them, learn to dance with that uncertainty. Look at Jupiter's moons, for example, the 4 Galilean moons, Io, Europa, Ganymede, and Callisto. They orbit close to the mighty Jupiter, yet they have solid surfaces, mountains, valleys, their own stories. Io is full of constantly erupting volcanoes. Europa has a subsurface ocean of ice. Ganymede is the largest moon in our solar system and has its own magnetic field. And Callisto has an ancient surface filled with impact craters. What do these moons teach us? They teach us that even under the influence of something as vast and boundless as Jupiter, they still maintain their own form and identity. They have ground to stand on, even if that ground is constantly bombarded by immense gravitational forces. Perhaps our lives are similar. Even if we feel like we're sinking into uncertainty, we can still create our own ground built from self-understanding, inner strength, and the ability to adapt. Perhaps the most frightening thing isn't falling, but falling without knowing when you'll stop. And perhaps not knowing when you'll stop isn't always a bad thing. It might be an opportunity for us to explore unknown depths, to discover strength we never thought we had, to learn to float in the currents of life without clinging to an invisible ground. Some periods of life are like Jupiter, deep, vast, and with no stable place for us to stand. But in that uncertainty, in that endless depth, there can always be beauty and new understanding hidden. Just like the mystery of Jupiter that continues to invite us to explore and learn endlessly. And like its moons that, despite being close to the giant, still have their own worlds for us to discover. May all you listeners find your own stable ground within yourselves, no matter what depths and uncertainties you may face. In the vast expanse of space, one planet stands out with a quiet, majestic grace, adorned with a magnificent system of rings that wrap around it like the crown jewels of the cosmos. It is Saturn, the sixth planet from the Sun, and one of the most captivating wonders of our solar system. Humans have gazed up at Saturn for thousands of years, even in ancient times, when astronomers had nothing but their naked eyes. They marveled at its steady golden glow. They named it after the Roman god of agriculture, Saturn, the father of time. But it wasn't until the invention of the telescope that we truly began to grasp its complexity. In 1610, the great Galileo Galilei became the first person to point a lens toward Saturn. What he saw left him baffled. He described what looked like ears protruding from the sides of the planet, which we now know were the edges of its grand ring system. The rings aren't the only thing that makes Saturn special. It is a gas giant, which means there is no solid ground to stand on, like there is here on Earth. It is composed mostly of gases, primarily hydrogen and helium, much like the Sun, though on a much smaller scale. Despite its gaseous nature, Saturn is colossal. With a diameter of about 120,000 kilometers, it is 9 times wider than Earth and nearly 95 times more massive. Yet, remarkably, it is less dense than water. If you could find a bathtub large enough, Saturn would actually float. Beyond its rings, Saturn is a guardian to a vast family of moons, over 80 confirmed so far, each with its own story. There is Titan, with its thick atmosphere and lakes of liquid methane, and Enceladus, which sprays plumes of ice from beneath its surface, hinting at the possibility of life. Saturn is more than just a point of light in the night sky. It is a world of mystery, beauty, and terrifying power. But have you ever wondered what it would be like if you didn't just look at it from a distance? What if you were to experience it firsthand? Imagine for a moment that you are floating high above Saturn. The iconic rings shimmer brilliantly below you. You feel the immense void, the absolute silence, and then a subtle, persistent pull. You are falling into Saturn. Your breath hitches, and your heart begins to race. You reach out, trying to grab onto something, anything, but there is nothing. Only the endless, empty reach of space. And so, your journey begins. You start to feel the friction. A golden yellow haze appears before you. These aren't the soft white clouds you know from Earth. This is a thick, suffocating blanket of frozen ammonia gas. At this altitude, the cold is biting, somewhere between -170 and -110 degrees Celsius. The atmospheric pressure isn't overwhelming yet, feeling much like the pressure at sea level on Earth. Looking up, you can still see the rings stretching across the sky. The horizon is a deep, dark blue, reminiscent of twilight on Earth. But there is no bright sun to guide you, only a dim, filtered light struggling to reach down. The wind begins to pick up. It grows stronger and more violent until it feels like it's tearing at you. Your body starts to tumble, spinning out of control. You try to steady yourself, but it's impossible. You look down into the waiting darkness. You look up, and the sunlight is fading away. You might wonder, is this the end? No, this is only the beginning. As you fall deeper, the winds become a literal force of nature. Wind speeds on Saturn are staggering, reaching up to 100 to 800 kilometers per hour, many times faster than the most powerful hurricanes on Earth. It feels as though the very air is trying to rip you apart. You are diving through layers of complex clouds, ammonia, ammonium hydrosulfide, and water ice. Each layer has its own density and color, creating breathtaking patterns that hide a violent, chaotic storm. The pressure around you is mounting. It feels as if hundreds of elephants are standing on your chest. Every movement is a struggle. You feel your body being compressed from every direction. The temperature begins to shift. The freezing cold of the upper atmosphere gives way to a rising heat. But it isn't a comfortable warmth. It is a searing heat generated by the sheer compression of the gas and the planet's own internal energy. You reach out for something to hold onto, but it's useless. Saturn has no surface. It is a gas giant. There is no ground to catch you, no place to rest. You simply keep falling. Swirling clouds whip past at incredible speeds. Bolts of lightning crackle all around you, and the roar of the storm is deafening. This is a world unlike anything you have ever known. As you plunge even deeper, the pressure and temperature reach unimaginable levels. The hydrogen gas, crushed by the planet's massive gravity, begins to change. It is squeezed so tightly that it turns into a liquid. You are now falling through a vast, glowing ocean of liquid hydrogen. This ocean has no shore, no surface to break. It is a gradual, heavy transition from gas to liquid. The density keeps increasing until it feels like you are swimming through a thick, viscous fluid. The last traces of sunlight are gone. You are in total, absolute darkness. The only thing you feel is the heat radiating into every fiber of your being. The pressure at this depth would crush anything we know. Even the strongest spacecraft would be flattened in an instant. Without some kind of impossible protection, a human body would have been pulverized long ago. But you continue to fall. There is no bottom. There is no stopping. The sensation of sinking into this infinite void, this bottomless ocean, is both terrifying and awe-inspiring. You are the first explorer to ever witness the true depths of Saturn. Deeper still, the liquid hydrogen is compressed into a bizarre state called metallic hydrogen. Under pressure millions of times greater than Earth's atmosphere and temperatures hotter than the surface of the Sun, hydrogen atoms are crushed until their electrons break free. It begins to act like a metal, conducting electricity. You are falling through a swirling ocean of liquid metal. The massive electrical currents flowing through this layer are what generate Saturn's powerful magnetic field, the same field that protects the planet from solar winds and creates the stunning auroras at its poles. In this dark, crushing chaos, you might imagine diamond rain falling from above. Methane molecules from the upper atmosphere are torn apart by the heat and pressure, turning into carbon, which is then squeezed into diamonds. These gems rain down toward the center of the planet, though you would never see them in this hostile, unforgiving environment. Finally, your journey reaches its ultimate destination, the core of Saturn. This core is believed to be a solid ball of rock and ice, roughly the size of Earth, but far denser. The temperature here is a staggering 11,000 degrees Celsius, twice as hot as the surface of the Sun. You have traveled 45,000 kilometers into the heart of the planet. It is a journey with no escape. Even at the core, gravity holds you tight. There is no place to stand, no way out. There is only the eternal embrace of the heat and the dark. What does falling into Saturn teach us? It is a confrontation with the sheer scale of the universe, a reminder of how small we are and how limitless nature can be. Sometimes, life feels like falling into a place with no floor. We don't know what comes next. We can't control everything. That uncertainty, that feeling of being out of control, can be the most frightening thing of all. We reach for stability, for something solid to hold on to. But sometimes, those things just don't exist. Yet, in the darkness, in the void, in that loss of control, we might learn something about ourselves, about courage, about resilience, and the ability to face the unknown. It is the acceptance that some things are beyond our understanding and beyond our control. And perhaps that is where the true beauty of life lies. This journey may have no end, but every step, every moment that passes, carries meaning. It is an experience that changes you. And perhaps The most terrifying thing isn't the fall itself, but not knowing when we will ever stop. Or maybe this endless journey is the true meaning of existence. Imagine for a moment a night where the stars are shimmering, where the whole world is asleep, and even the whisper of the wind has fallen silent. You are floating weightlessly in the dark void of space, where silence isn't just the absence of sound, but a tangible emptiness you can almost touch. A silence so deep that you can hear the very rhythm of your own heartbeat. No wind blowing past, no waves crashing, no birds singing, nothing at all, except for a silence that blankets everything. A silence without boundaries and without time. But within that endless silence, in a darkness that seems to hold nothing, something is moving. Something far greater than human imagination, something hidden and more dangerous than we could ever guess. It is a mystery waiting to be revealed, a truth hidden beneath a veil of calm. And tonight, we will journey into that silence together. We're talking about Neptune, the deep blue planet, known as the ice giant of our solar system. It's the 8th planet, the one farthest from the Sun. By the time sunlight reaches that far, it's weak and flickering, like a single candle trying to light up a pitch-black room. It takes over 4 hours for light to travel to Neptune, and it's only a fraction of the intensity we feel here on Earth. This leaves Neptune submerged in eternal darkness and cold. That deep azure hue isn't just for show. It's scientific evidence of what's in its atmosphere. Methane gas in the upper layers acts like a natural filter, absorbing the red light from the sun and reflecting that signature blue back into space. It makes Neptune look like a sapphire jewel floating in an infinite void. It's beautiful, serene, and filled with a mystery that draws you in. From a distance, through a powerful telescope, Neptune looks like a peaceful world. No chaos, just faint white clouds drifting over a dark blue surface. This cold, quiet exterior is what misleads so many people, making them think it's a lifeless, uninteresting planet. But the truth is, behind that beauty and silence, something is hiding, something powerful, violent, and dangerous beyond imagination. It's a world of contradictions, between the peace on the surface and the turmoil hidden within. In the vastness of space, silence is the norm. There's no air for sound to travel through, no molecules to vibrate and carry sound waves. So, Neptune is a truly silent world. No roar of storms, no whisper of wind, none of the sounds we know on our blue marble. But this absolute silence is a thin veil, masking a shocking reality. From the outside, looking through a distant telescope, Neptune appears still, frozen, like an oil painting where time has stopped. No signs of chaos, no traces of violence, just pure, radiating beauty. Yet beneath that deceptive calm, there is constant, violent motion. It's a dance of massive energy, a collision of invisible winds, and the formation of storms that never end. It's a profound metaphor that stillness doesn't mean nothing is happening. Sometimes, the things that seem the most stationary are the ones building up, gathering energy, or facing immense unseen forces. Just like Neptune, its silence tricks us into believing everything is safe, hiding a terrifying truth and inviting us to step closer, only to discover what lies behind that curtain of silence. And what's hidden beneath that calm are the most violent storms in our solar system. Storms that don't roar, yet are terrifyingly powerful. Winds on Neptune can reach speeds of over 2,000 kilometers per hour, sometimes even 2,400. That's faster than the speed of sound on Earth. Imagine that. While you feel like everything is still and silent, The strongest winds in the solar system are raging around you, at speeds that could tear anything apart in an instant. The most famous of these is the Great Dark Spot. It's a massive swirling storm, large enough to swallow our entire Earth. First discovered by Voyager 2 in 1989, it appeared as a dark oval on Neptune's blue surface. Even though it looks dark and cloudless from the outside, inside is a chaos no one could survive. It's an anticyclonic storm, spinning at incredible speeds, with an unpredictable lifespan. Sometimes it appears, and sometimes it fades away, leaving only the mystery of what drives it. Close your eyes and imagine you're floating above the deep blue clouds of Neptune. Everything seems peaceful, silent. The faint sunlight hits the clouds, casting long shadows. But then, you start to feel an invisible pull. The wind begins to pick up speed. It's not the roar of a storm you're used to. It's the sensation of being torn apart, of being swept away in no direction, without any warning. You'd feel an immense pressure on your body, the temperature dropping rapidly, and a total loss of control. That is the terror of a storm on Neptune, a silent storm, yet powerful enough to crush anything in its path. If you ever had the chance to visit Neptune, your experience might start with a captivating peace, a peace unlike anything you've ever felt on Earth. You'd float in an infinite silence, watching the faint sunlight hit the dark blue clouds, creating an illusion of stillness. The deep azure of this giant planet. Everything would seem to stop, letting you soak in the pure beauty of the universe. A feeling of being part of a grand emptiness. But then, that peace would slowly be replaced by a strange sensation. Something hard to describe. You might not even realize that you're being pulled into an invisible current. A current that doesn't roar, but carries massive power. The wind picks up, from a gentle breeze you can barely feel, into a violent storm that tears through everything in its way. Whether it's chunks of ice, or even you. You'd feel a cold that bites to the bone, a cold that seeps into every cell of your body. Temperatures hundreds of degrees below freezing. The wind would be so strong you couldn't keep your balance. You'd be swept away aimlessly, spinning in a raging current, with no ground to stand on. Nothing to hold on to in the vastness of space. You'd become just a tiny fragment of an endless storm, a storm without mercy, ready to swallow anything that comes near. This is the truth hidden behind Neptune's silence. A dangerous silence, a deceptive silence, a silence that can turn a beautiful dream into a nightmare in an instant. It's a lesson that teaches us, sometimes, the things that seem the most peaceful can be the most dangerous. The story of Neptune isn't just a fascinating scientific tale. It makes us look back at our own lives and question what we see, what we hear, and what we believe. Sometimes, the quietest things in our lives can be the most intense, or something that is quietly building up, waiting for the day it erupts, like the storms on Neptune hidden beneath a deceptive calm. Look at the people around you. Some seem so still, showing little emotion, rarely speaking. But who knows what's happening inside? What kind of emotional storm they might be facing? Hidden feelings, swirling thoughts, gnawing anxieties. It could be a storm in the heart that no one sees and no one hears. A storm that might be more violent than any storm on Neptune. We often judge people from the outside, by their calm demeanor, their gentle smile. But we never know what they're fighting against beneath that surface, what kind of challenges they're facing, or how much weight they're carrying. Their silence might not be emptiness. It's a space filled with stories, filled with feelings, and filled with energy waiting to be released. Just like Neptune, its silence doesn't mean it's empty. It's full of invisible energy. Our lives are the same. Silence can be a space where we reflect, where we face our inner feelings, where we understand the storms in our own hearts. Or it could be a time when a storm is quietly gathering, waiting for the day it sweeps us toward change, toward growth, and toward discovering a truth about ourselves that we never knew before. Neptune, the deep blue ice giant floating in the distant darkness. It doesn't make a sound. No roar of storms, no whisper of wind, just a silence that covers everything. But that doesn't mean it's gentle or powerless. On the contrary, beneath that silence, it hides the most violent storms in the solar system. Storms that can tear everything apart in an instant, without a single warning. And perhaps the story of Neptune reflects a certain truth in our own lives. The quietest person in the room, the one who seems the most at peace, might be the one fighting something no one else can see. A storm in the heart more violent than any on Neptune, a storm of anxiety, of fear, of disappointment, or hidden desires. In a universe this vast, filled with so many mysteries we still don't understand. Silence might not be emptiness. It's not the absence of anything. Instead, it might be full of things we don't yet understand, things we haven't yet discovered, or things we aren't yet brave enough to face. Imagine for a moment that you're standing on a planet far, far away. Not the Earth we know, not the moon we see every night, but a world so distant that the sun is just a tiny flickering speck in the vast darkness of the cosmos. This world doesn't stand tall and upright like ours. It's tilted so far it's almost lying on its side, like a sleeping giant drifting through space. It orbits the sun in a strange, unique way, unlike any other planet in our solar system. And yet, despite that extreme tilt, it keeps on spinning. Slowly, steadily, as if nothing is wrong. It's a world that tells a story of difference, of solitude, and of the hidden beauty found within imperfection. Can you feel the biting cold, the boundless silence? Look up at the deep indigo sky, adorned with millions of stars. You are part of this mystery now, a witness to the strange, lonely dance of this distant world. This is the story of Uranus, the planet that tilted but never stopped spinning, the one that truly stands alone in our universe. Uranus, often called the sideways planet, is the seventh world from our sun. It's what we call an ice giant, a massive world made of water, methane and ammonia ices surrounding a small rocky core. From a distance, Uranus looks like a soft blue-green marble. That unique color comes from the methane gas in its atmosphere, which absorbs red light from the sun and reflects back a gentle pale blue, like a jewel floating in the dark. It's so far from the sun that the concept of warmth is almost non-existent. This immense distance makes Uranus one of the coldest places in our solar system, with temperatures dropping to a staggering -224 degrees Celsius. It's a cold so intense it could freeze almost anything in an instant. A single journey around the sun takes Uranus 84 Earth years. Just think about that. 1 year on Uranus is an entire human lifetime on Earth. Throughout that long, slow journey, it reveals the secrets hidden beneath its soft blue clouds. What makes Uranus truly fascinating is its tilt. Its axis is tilted at nearly 98 degrees. While Earth spins like a top, Uranus spins like a ball rolling on its side. Scientists believe this strange tilt might have been caused by a massive collision with an Earth-sized object long ago. That crash didn't destroy the planet. Instead, it gave Uranus its identity, a planet that dances to its own rhythm, unlike anything else in the solar system. This extreme tilt creates seasons that are both strange and incredibly long. While our seasons change every few months, a single season on Uranus lasts over 20 years. In some parts of the planet, the sun shines continuously for decades. It's as if the day never ends, with that pale blue light washing over the frozen landscape, revealing its cold, quiet beauty. In other parts, the world is plunged into total darkness for decades at a time. The sun never rises. There is only the faint glimmer of distant stars and a cold that reaches deep into the planet's core. This is a world where the extreme is normal, where imbalance is part of the balance. It teaches us to see the value in being different. If you could visit Uranus, you'd experience something unlike anywhere else in the universe. The sky above would be a deep, soulful indigo, dotted with thin, wispy clouds of methane. The sun would look tiny and far away, a dim light that offers no warmth. You'd feel a silence so profound, it's almost heavy. A silence where you can hear your own heartbeat and your thoughts echo in the vast emptiness. But where would you stand? There is no solid ground here. You would simply float within a massive atmosphere that slowly transitions from gas to liquid and eventually into ice compressed under unimaginable pressure. The silence would be the most striking thing of all. No wind, no waves, no sound of life. Just the infinite quiet of space. It might make you feel small, perhaps even lonely. But at the same time, it reminds you of how vast the universe is and how special it is that you exist within it. In that stillness, you might catch a glimpse of the thin, dark rings surrounding the planet, crowns of ice and dust reflecting the faint sunlight. And looking out further, you'd see its 27 moons, each with its own story, orbiting in that same tilted plane, like a family dancing together in their own unique way. Despite its beauty, Uranus is a harsh and unforgiving world. The winds here are incredibly violent, reaching speeds of up to 900 kilometers per hour. These storms tear through the atmosphere in a wild, chaotic dance of nature. And deep inside, the pressure is so intense that methane might be squeezed into actual diamonds, falling toward the core like a never-ending rain of precious stones. Even its magnetic field is strange. It doesn't come from the center of the planet like Earth's. It's tilted and offset, originating from a shallower layer of liquid. It remains one of the great mysteries that scientists are still trying to solve. Uranus is a world of extremes, frozen beauty, and unreachable harshness. It's a reminder that our universe is full of diversity and mysteries waiting to be found. The story of Uranus isn't just about a distant planet. It reflects parts of our own lives. Uranus doesn't stand straight. It's tilted. It's different. It's unique. And yet, it survives. It keeps orbiting the sun. It stays true to itself. Sometimes we feel like Uranus. We might feel like we don't fit in, that we're tilted or different from everyone else. But the important thing is that we keep spinning. We keep living our lives, being exactly who we are, no matter how the world sees us. Uranus teaches us that being different isn't a weakness. It's what makes us stand out. There is beauty in imperfection and strength in accepting who you are. It's a reminder that even in the darkest, coldest moments, there is still beauty to be found. Even if our path isn't as straight as we expected, we still have the power to keep moving forward and create a story that is uniquely ours. Sometimes life doesn't go the way it's supposed to. We face obstacles, disappointments, or the feeling that we just don't belong. We might be tilted, like Uranus, drifting away from the path society expects or the dreams others have for us. We might be different from the majority, with thoughts, dreams, or a way of life that is entirely our own. But in that tilt, in that difference, we keep spinning. We keep searching for meaning, we keep growing, and we keep being ourselves in the most beautiful way possible. Because in this vast universe, diversity is beauty, and being unique is the power that makes us special.